My name's Randy West. I'm the director at NCAT, and it's my pleasure to welcome you all to the National BMD Implementation Conference. I just got a few things I wanted to say before we get started with the program. First of all is to thank some different organizations. First of all, the AAPT board for letting us kind of piggyback this at the end of their conference, which has been very helpful in making arrangements and so forth. And we're glad to have, some people that stayed over from the AAPT meeting for this as well. One thing while I'm thinking about it is there is a Wi-Fi for this meeting, and it's actually the same Wi-Fi and password as for the AAPT meeting. And for those of you that weren't here, you may see AAPT annual meeting as a Wi-Fi choice. And then the password is AAPT 2021, and AAPT is all caps. So if you have any needs about that, find one of us that's been here for the rest of the week, and we'll be able to help you out. Also, I'd like to say that this conference is being sponsored by NCHRP. It's NCHRP 20-44/27, which is facilitating BMD implementation. And this conference and some of the other things we're doing as part of this NCHRP project, it's actually a follow-up to an earlier NCHRP project that NCAT did, finished in 2018, that was establishing the BMD framework. And part of that framework was creating the provisional AASHTO standards that are balanced mixed design. So those are things I'll reference later, later this morning or later this afternoon. The last thank you I need to make is to NAPA, the National Asphalt Pavement Association. They are sponsoring the reception this evening. So thank you, Richard and Audrey. And so we'll enjoy that. For all the people that are virtual, we'll toast you from afar and enjoy a drink on your behalf. So just to let you know, I think we had a little over 100 people registered for the conference in person. And so we're really happy about the turnout, considering, the situation we are continue to have with the pandemic. But we have also over 500 people registered virtually. And we probably could have had a lot more than that, but I had to cap it at 500 for some logistic reasons for the breakout sessions that we'll have tomorrow. So I'm going to go through just a few introductory slides. First is just kind of go through the agenda for this afternoon and tomorrow. It's a fairly compressed agenda, but I think we're going to accomplish a lot seeing this. So this afternoon, we'll hear really some case studies from 3 DOTs and 3 contractors in those states about their experiences with balanced mixed design so far. And then we'll have the reception this evening. And then tomorrow morning, we'll have some more different topics talking about. I'll present kind of a BMD implementation guide that we're working on. And then we'll have 2 presentations from 2 more states that are going to present their benchmarking studies, Maine and Wisconsin. In the latter half of tomorrow morning, we'll have breakout sessions and discuss some real important topics on issues related to balanced mixed design that we need to discuss. We don't have all the answers. We're trying to implement BMD, and there's still some questions that we need to kind of work out as we go through this process. So that'll be a chance for everybody to have some interaction. We're going to do it live in this room, and we'll do it virtually as well as in some breakout sessions on Zoom. So hopefully that will go well. And then I'll wrap it up with hopefully a summary of some of the feedback from those breakout sessions. Lastly, I want to point out to you on the bottom of the agenda, and on this slide as well is this QR code, and this is also on the printed version of your agenda. This QR code will take you to some resources, some publications that you may find very useful in the implementation of balanced mix design, whether you're a contractor or an agency. First is FHWA and their work with the University of Nevada, Reno are putting together BMD virtual workshops. So that first one is a flyer just introducing those workshops. The second one is a collection of case study reports from 6 states that are kind of the some of the early adopter states for balanced mix design. So there's a report in there for California, Illinois, Louisiana, Maine, New Jersey, and Texas. You'll find those very interesting and useful. There's also a fairly recently released FHWA tech brief on asphalt material quality assurance practices. And I think there's a webinar coming up on that as well. You may have seen that being announced in some different social media. The next one down is NCHRP 2007 Task 406 BMD Framework Final Report. So that's the study that kind of got NCAT started looking at BMD kind of on the national level. That's the study that produced the AASHTO provisional standards for balanced mix design. And there's a lot of useful information in that report, even though it's now about 3 years old. The next one down is a NAPA publication, IS 143, which is the BMD resource guide. This is a print version that's available from NAPA. They also have an online BMD resource guide. I don't know, is that still open to everyone? Okay, it's still open to all stakeholders at this point in time. There's useful information being added to that website. So hopefully that will be a good reference for you. The next one down is the NCAT Cracking Group report. This is a report that summarizes the cracking field versus lab study that we completed earlier this year. It's got a lot of different cracking tests and correlations between cracking on the test track and cracking from those different tests. So it's a very useful and kind of up-to-date report. And then the last one is a synthesis report on practices for fabricating specimens for performance testing. And anybody that's already been hands-on with these BMD tests, you know that sample fabrication is such a key part of getting repeatable results and meaningful results. So that'd be a really good guide for making sure we follow good practices in doing that. See if I got anything else. I think that's it for me. I'm going to go ahead and ask Derek Niederplant to come up. He's going to be the moderator for this afternoon. And Derek is, make sure I get his title right, pavement materials engineer with the FHWA Resource Center, the pavement materials technical services team. So come on up, Derek, and get us started. Thank you.
Thanks, Randy. Again, for those of you who don't know, my name is Derek Niederplant with Federal Highway. And again, I'll be moderating this afternoon session. We'll be going through case studies, state and contractor experiences, putting together a balanced mix design. Just a couple comments before we start. You know, this is really unique meeting and conference here today. We were really focused on the implementation. Balanced mix design has been talked about at a lot of levels, but often it's the research. It's the purely technical items really that we're looking to focus. And I think we have some speakers in discussion today to take that and put that into practice. How do you put it into practice? And that's what the focus of this, and it's really unique, and appreciate the opportunity to be part of it. As far as Federal Highway, you know, we're excited to support agencies on their road to implementing balanced mix design. We've been collaborating with NCAT on some of this information as well. Randy mentioned our workshop that we're certainly offering out to agencies and states to aid them in seeing the road ahead to get to balanced mix design implementation. So certainly feel free to catch me at any time over the next day, and I can certainly talk to you about it. For to this afternoon's session, we're going to go through states, Vermont, Virginia, and New Jersey. What we will do is we'll have each the state DOT and the contractor experience and present. We will hold questions. We do have a question and answer session all at once that we'll be doing. So for those of you in person, we'd ask just kind of maybe write your question down or hold it. And for those of you online, you can type it into the chat, but we won't get to it until we do the full question and answer session later. Right. So with that, we'll kick it right off and get into our first state, which will be the state of Vermont. And our first speaker will be Aaron Schwartz. Known Aaron for a couple of years, and Aaron is the bituminous concrete engineer for the Vermont Agency of Transportation, where he has 6 years of experience, 5 of which at V-Trans. So everyone welcome Aaron.
Thank you, Derek. So good afternoon, everyone. My name is Aaron Schwartz. I'm the bituminous concrete engineer for the Vermont Agency of Transportation. And today I will be discussing the agency's perspective regarding the balanced mix design for what we've been doing. So first off, I want to thank our field and lab technicians at V-Trans for providing the for obtaining the split samples at the lab, and then having our lab technicians fabricate the specimens, reheating them to compaction temperature, and fabricating the specimens, splitting and for the Hamburg and the iFit. And then I would also like to thank the Vermont QC team with Pike Industries, as well as the central lab team at Pike Industries, as they were the contractor / producer for the 3 pilot projects that we did. And lastly, I would like to thank the National Center for Asphalt Technology for giving me the opportunity to speak today, and also especially Dr. Randy West for asking me to present. So first, I'm going to talk about the motivations for why we decided to go with balanced mix design, as well as the tests that we did, the initial benchmarking that we did, our selected BMD approach, the pilot specification itself. I will briefly go over the 2019 projects that we did along with the 2020 projects, discuss some of the impediments and constraints that we found during using our tests in QA production. And then I will conclude I will summarize everything and then conclude with what we're doing moving forward. So the question is, why did we decide to move ahead with balanced mix design or start pursuing balanced mix design? So since 2008, under state law, we are required to consider or allow up to 50% wrap by weight in our asphalt mixes. And since 2018, we have allowed up to 3% RAS by weight in our mixes as well. It's worth noting, as I will indicate later in this presentation, that most mixes have no more than 20% wrap in general, because we have grade bumping requirements in our PG binder specification. In addition, we were also seeing various distresses in our asphalt pavements, mainly raveling and rutting on our limited access highway system, as in our interstates, basically. We were also seeing all 3 cases of cracking, as in fatigue cracking, thermal cracking, and reflective cracking. And this is because of what I like to say, we are an unintentional composite pavement state on our regular roadways, because there are concrete slabs dating back from the 1930s and 1940s that were placed below the asphalt pavement layers. And as most of you can attest to in the room, what we found with the original performance tests developed with the super pave mix design methodology was that they were too complex and the equipment was too expensive. So in Vermont, we only implemented the volumetric aspects of super pave. And lastly, and most importantly, we wanted to increase the amount of collaboration that we have with the asphalt producers and amongst ourselves, because we share a common cause, ensuring that the right materials are being used at the right cost and at the right time. So now I'll talk about the balance mix design tests that we chose. So in 2015, we purchased the Hamburg wheel tracker, and we chose that test to evaluate rutting and moisture susceptibility, primarily because it is a torture test in principle on HMA mixtures. And we suspected that raveling was moisture susceptibility related. And in addition, we also shared a mutual dislike with the asphalt paving industry in Vermont regarding the TSR test parameter that's performed in accordance with AASHTO T283. We thought as though it did not reflect the actual moisture susceptibility and stripping issues that we were seeing in Vermont. And then for the cracking side of balance mix design, we chose the Illinois Flexibility Index because it was identified as a candidate test for thermal and fatigue cracking in NCHRP project 9-57. And at the time we made this decision in 2017 is that we were anticipating an increase in our recycled asphalt materials content, particularly RAS, which we did implement in 2018, as I noted before. We did look at the other two SCB tests, Louisiana and the Minnesota test, but we either found them to be not used outside the southeastern US in the case of Louisiana SCB, and we considered the Minnesota SCB tests to be too expensive for what we needed because we needed to purchase an environmental chamber. So next I'll talk about the benchmarking, and upfront I will say that benchmarking has been the most challenging aspect of incorporating balance mix design in Vermont. So we began sampling plant-produced mixtures in 2015, soon after we purchased our equipment. And essentially, we reheated specimens up to compaction temperature. Initial specimens were gyrated to 60 millimeters per T324, the AASHTO procedure, but since last year, we've been gyrating to 62 millimeters per feedback in our paving association meetings. We initially did testing at various temperatures ranging from 40 degrees Celsius to 55 degrees Celsius. But then in 2016, FHWA suggested that we test all specimens at 45 degrees C due to the climatic conditions in Vermont and to align with procedures in our neighboring states, Maine and Massachusetts. And after we presented our initial data in the winter 2017 meetings with our paving association, the producers began split sampling plant-produced mixtures and following the same fabrication procedures that we were, assuming they had Hamburg equipment in their labs, and almost half of the producers as of this year now have Hamburg equipment in their possession. Also in 2017, there was an executive level decision made to mandate the use of polymer modified binders for all agency paving projects moving forward. And because of concerns in our paving association meetings regarding the massacre test at the time and tank storage requirements, we decided that the simplest path forward was just to specify PG 7028 binder as a baseline. So allow me to go over the 2015 and 2017 data very briefly. Most of the data from 2015 and 2017 consisted of varying PG binder rates, as indicated on my slide. All the data from 2015 wasn't entirely tested at 45 degrees Celsius. And for that reason, and along with the fact that most of the softer binder mixes tended to fail at 12.5 millimeters before reaching 20,000 passes, in addition to our programmatic switch to PG 7028 binders, we ended up not using that data in constructing our pilot specification. So now I'll talk about the 2018 data. As you can see, the average and standard deviation rut depth for mixes with PG 7028 binder was 4.1 millimeters and 2.22 millimeters. For PG 5828 binders, it was very close to hitting 12.5 millimeters rut depth as an average. Not shown on this slide is the average rut depth and standard deviation for our 9.5 millimeter mixes, which we use as our wearing course. And that is 6.85 millimeters and 4.15 millimeters as a standard deviation. And I will get into detail about that a little later. It's also worth noting that most mixes with 7028 binder did not strip based on visual analysis of the final plot, where the strip slope was less than the creep slope, or began stripping after 15,000 passes. So for our initial benchmarking of the iFit, we began sampling plant-produced mixes in 2018. All procedures in the AASHTO method were followed, with the one exception being that we were gyrating specimens directly to 50 millimeters instead of fabricating 160 millimeter specimens and then cutting 50 millimeter slices out. And that was because we were on the fence about whether we wanted to purchase a tile saw or not. We eventually did during the middle of the construction season, but in our first attempt at following the proper procedure, one slice of the 160 millimeter specimen ended up being 52 millimeters thick on one side and then 48 millimeters thick on the other. So that was an oversight on our part, and we realized that we needed to purchase an additional jig, which we did. And after some trial and error in winter 2019, we have been following the proper AASHTO procedure ever since, starting in the 2019 season. And likewise, the producers began split sampling of plant-produced mix for iFit and following the same procedures. We were assuming they had the equipment, and as of a few weeks ago, half of the producers in Vermont now have iFit test equipment. So the 2018 data for the iFit, like I noted before, was entirely consisting of specimens that were fabricated directly to 50 millimeters. And it's also worth noting that the majority of results from 2018 consisted of mixes with 20% wrap, and there were no virgin mixes used whatsoever. It's also worth noting that as you'll see with the type 2, which is our 19 millimeter mix, as you'll see in the table, the average flexibility index was 13.5 and the standard deviation was 4.77. And that we thought was alarming, and we realized that was because most of the material came from one specific plant for one specific project. And it was also worth noting that we did not see any major differences between mixes with PG 5828 and PG 7028 binder. So based on this initial benchmarking, what we concluded was that we didn't have enough reliable data for our 19 millimeter or 12.5 millimeter mixes to include them in our pilot specification. So we ended up using only our type 4S 9.5 millimeter mixes if they were being used as a wearing course in our specification. And we were comfortable with the numbers we were getting out of the Hamburg, but we wanted to we wanted the mixes, or we wanted the FI criteria to be strict, if you will, such that the mixes were a little bit more soft in general. So we did that. So in order to develop our criteria, we just used the average and standard deviation and raised or lowered the bar accordingly based on which test was being done. We also realized in our discussions in our Winter Paving Association meetings that plant mix lab compacted specimens are not the same as lab mix lab compacted specimens, and that we needed data to represent conditions at every point in the mix design, during the mix design stage, if you will, meaning specimens for balanced mix design needed to also be tested in the same way that mix designs are generated. So we issued an addendum, which in Vermont we call a general special provision for all projects beginning in 2020, requiring that Hamburg and iFit results be provided for informational purposes only, such that we can capture mixes that we were not split sampling or anything of that nature. And like I noted before, benchmarking has ended up being the most time-consuming aspect overall, and we're still doing it to this day. So now I'll talk about the mixed design procedure in Vermont. In Vermont, it's largely a paper check overall, but we do improve the constituent ingredients like the PG binder and the aggregate sources on an annual basis per our quality assurance program. We used to require mixed design specimens to be provided or shipped over to the lab for approval, but we found that to be redundant at some point. We generally look at air voids and VMA and ensuring that the gradation and aggregate consensus properties are compliant with our specifications and the AASHTO standards. We have not been able to distinguish a direct link between designing to 4% air voids and our observed pavement stresses. So we haven't seen a reason to adjust our 4% air voids target for mixed design approval as part of this balanced mixed design. And for these reasons, we've chosen approach A as part of our specification, which is volumetric design with performance verification. So now I'll get into the details regarding our special provision. So we developed the same criteria for both mixed design and during mixed production. And we realized in hindsight that was not the best idea. So for the Hamburg, we specified a maximum rut depth of 10 millimeters overall and a stripping inflection point minimum of 15,000 passes. And then for the iFit, we specified a FI of 10.0 minimum. We also eliminated TSR testing completely, and this was largely based on findings in New England Transportation Consortium Project 15-3, which validated our concerns that the TSR test parameter was not reflective of moisture susceptibility and stripping in Vermont. So for our pilot spec, we decided to do a percent within limits approach for QA. So we set an arbitrary rejectable quality limit, or RQL, of 60% for the rut def, SIP, and FI during mixed production. And if the PWL fell below 60% during production, corrective action would need to be done by the contractor to bring the mix back into compliance. And if corrective action was unsuccessful, then the mix design that was used would be rescinded. So I'm not going to spend too much time on these two pilot projects that we did because, as you can see, the quantities were rather small, being under 10,000 tons. The key difference between these two projects was that one project had a design gyration specified as 50, and then the other had a design gyration specified as 65 gyrations. And one important thing to note is that in Vermont, our QA specifications define an air voids lot as 3,000 tons. So we decided to align the sampling frequency for performance testing such that there would be one set of performance test results for each air voids lot, in essence, creating the performance test sublot. However, on the second project noted below, I made a mistake in determining the final tonnage that was going to be used on that project. So the contract was amended via a written order by the resident engineer of that particular project to change the sampling frequency and testing frequency for our BMD spec to 2,000 tons per lot in order to yield 3 sublots to calculate a PWL. So for the mix design on the first project, the rut def and SIP were fairly well. It's worth noting that the SIP for this particular project was basically spit out from the machine directly, the contractor's Hamburg machine directly. And the flexibility index was 17.2. As you can see with the results during production, the mix was generally softer overall. The PWL of 67 for the stripping inflection point was likely due to the fact that the very first sublot was ended up stripping below 15,000 passes. And we cannot explain why that occurred, given that the mix design did not strip whatsoever. So for the second project, the Interestingly enough, the average rut depth was 6.5 millimeters, which we found interesting considering that this project specified 65 gyrations, whereas the first project specified 50. And the FI was extremely high, but then as you can see during production, the FI became something more realistic, if you will. And again, the stripping inflection point PWL during production was 57, which was below the RQL. But by the time we calculated that PWL, we were not able to enforce the corrective action mechanism in our spec because production had ended on that particular project. So from 2019 and 2020, we took another look at the special provision, made some minor adjustments to the language to address some issues that we found. And we also identified a larger project for the 2020 construction season. This new project that we chose ended up being close to 27,000 tons overall, which yielded 9 sublots of performance test results. And design was 65 gyration. And like the first 2 projects, producer Pike Industries chose to utilize 20% wrap. So during the mixed design results overall were fairly good. They met the specification overall. And then during production, everything had a PWL of 100, but as Cheng will note in his presentation, there were some concerns that we do need to address further down the road. So there are some impediments and constraints to using the Hamburg and the iFit in mixed production overall. For us, one of the issues was data retention. For the project in 2020, there was a network outage issue that caused the first sublot of Hamburg results to not save in real time as the test was being ran. So because of that, we basically tossed out the first sublot from the PWL calculations overall, because that would have messed everything up, and we only treated the results for the first sublot as investigative only. In addition, we sometimes see noise in our Hamburg test equipment in one of the wheel path measurements, and we've attributed that to an electrical issue in one of the wheel path LVDTs. And this has been a recurring issue for us since the 2017 season. And basically, the data from the 2017 season was not necessarily used in any data analysis because we found the data to be unreliable when the noise was most prevalent. Another issue that we found was that turnaround time in mixed production is also an issue. So in Vermont, under our math density spec, which involves testing roadway cores, acceptance testing must be turned around, or excuse me, let me start over. Roadway cores for mat density acceptance must be turned around no more than 10 days after the specimens arrive at our lab. For the pilot projects in which we piloted balanced mix design, performance test results were turned around within a month after the materials were sampled at the plant. But typically, whenever we split sample, it usually doesn't happen until at least a month after the specimens are sampled and arrive at the lab. And sometimes the testing will not occur until after the construction season is over. And in Vermont, the winters can get very cold, so there's a lot of downtime. The first few months of the COVID pandemic kind of exacerbated these issues, and there was a delay in processing the results from the 2019 season. And lastly, another issue that we found was that we were starting to ask ourselves, is 3,000 tons too frequent, or is it just enough? What we realized is that you have to right size the sampling frequency for what type of paving project is being done, where the project is located, how much risk there is regarding other materials besides HMA, what level of oversight needs to happen by agency inspectors, everything of that nature. And for these reasons, we don't believe that the Hamburg and the iFit are appropriate for use in mixed production anymore as part of a QA specification. but we're comfortable enough to implement everything as part of a go, no-go specification for mixed design approval. And lastly, we find that aging in the relationship to field performance is important. In New England Transportation Consortium Project 18-2, our Hamburg and IFIT data was paired with data from the agency's pavement management system to draw a correlation. And unfortunately, I will concede that we have not conducted a site visit on any of the pilot projects or windshield surveys for that matter, to see how the pilot specification pavements are holding up, primarily due to COVID, but we have every intention of doing so in the near future. So in conclusion, the special provision that we piloted is unofficially on hold. We're not using it this time until we focus on other specification changes that we're making, including a tiered quality assurance approach for HMA, and that everything for mixture testing will have a pay factor tied to it. And we will also be incorporating the delta TC parameter for our PG binder specifications, and also move ahead with specifying the Massacre PG binder grading system under AASHTO N332. Right now, we're doing AASHTO N320, as you can probably guess. So for performance testing, we are looking at the ideal CT as a surrogate test during mixed production, or even as a replacement to the IFIT for mixed design approval. And we're going to start looking at the ideal RT as a surrogate test for the Hamburg during production as well. We've also began testing roadway cores in the Hamburg, and the reason why we're doing this is because, well, what better way to determine rutting and moisture susceptibility than by using samples representing in situ conditions after placement. We're continuing to benchmark all mixed designs, as I noted earlier, as part of designing a go, no-go specification for mixed design approval. And in addition, we are in preliminary discussions with the producers and third-party labs, and possibly with other state DOTs in the New England region to conduct a future round-robin study on performance tests. And lastly, we are asking the following questions, as in, what are the effects from aging on performance tests and mixture performance overall? What happens if we age the specimens and or volumetrics are changed? What happens if we design to 3% air voids, or if we design to 5% air voids, like what's happening in Indiana? Or what would happen if we decided to open up more sieves in our super pave specifications? And we also believe that an increase in recycled asphalt materials content is important. And a lot of these considerations we think will be answered by looking at aging procedures in the future. So again, I want to thank everyone for giving me the opportunity to speak today, and I will hand it off to my colleague Derek to introduce our next speaker.
All right, excellent. Thanks, Aaron, for kicking us off. Now to kind of complete the Vermont story here, we'll get the contractor's perspective from Cheng Ling, who is the technical manager with Pike Industries, which is a CRH company. He has his PhD from the University of Wisconsin and 4 years of experience with CRH companies and Pike Industries. So come on up and we'll get your presentation started.
All right. Good afternoon, everyone. And also to those who are sitting in front of the computer and watching our sessions. I hope everyone is staying safe and healthy. And it is my pleasure today to stand here and talk about our experience from the contractor's perspective during the balanced mixed design implementation in the state of Vermont. First of all, I would like to acknowledge Vermont Agency of Transportation for sharing their data as part of this presentation, and also their willingness to work with the paving industry during the specification development. I would also like to thank Pike Vermont Quality Control Team and the Central Lab team for their hard work during the sample preparation and testing. I'll first try to give a brief introduction about the BMD implementation status in Vermont and also Pike's effort during this process, and talk about some of our recent experience through a pilot project and the lessons that we learned from this pilot study. Other than that, I'll try to share some of our additional thoughts as regards to the potential mix adjustment in order to improve the balanced mix design test results, and also the next steps for us moving forward. I think Aaron has already talked a lot about the BMD implementation during his presentation, so I will just go over this slide quickly as a refresher. So VTrans has adopted BMD approach A, which is volumetric design with performance verification in their specification development. They issued the special provisions in 2019 and have constructed 3 pilot projects so far. In the special provisions, the spec limits were applied to type 4 9.5 millimeter mix only. And in the Hamburg, a maximum rod depth of 10 millimeter and a minimum stripping inflection point of 15,000 passes were required. And on the IFIT side, a minimum of 10 for the flexibility index was required on both short-term open age lab mix and also the reheated production mix. Other than that, a minimum quality level of 60% was also required during the PWL calculation through the production. Also note, starting from early 2020, both Hamburg and IFIT results are required in the mixed design submittal for other state projects, but just for information only. Also, as Aaron just mentioned, that the special provisions has been put on hold until further data collection is complete. Regarding the balanced mixed design effort at Pike, we first purchased the Hamburg machine for Vermont QC in 2017 and bought the IFIT jig along with the saws associated with this test in 2019. At that time, we also bought another set of test jig for ideal CT test, which turns out to be one of the very popular cracking tests across the country today. And earlier this year, we bought another set of hydraulic machine which can run both IFIT and ideal CT and set it up in one of our Vermont quality control labs. We have our senior QC technicians trained and run these performance tests. And running those tests are pretty simple and straightforward, and a minimum training is needed. However, interpreting the data and understanding the data took a little longer. Specifically for the IFIT data out of the test jig and the tablet, since that needs some extra data manipulation through the Illinois IFIT program. So that part took us a little longer before getting used to that. Also, we've been working very proactively with VTrans on the split sample testing, the data sharing, and also had a lot of great discussions on the specification development over the winter meetings. I'll talk about our recent experience from a pilot project that we constructed for VTrans in 2020 season. The project is Windsor Heartland resurfacing project as part of US 5 with a total length of 13.7 miles. It was constructed in summer 2020 with a total tonnage a little bit over 26,000 tons. The job was divided into 9 lots with 3,000 tons per lot. And the mix used was a type 4, 9.5 millimeter, 65 gyration mix. with polymer modified PG70-28 binder. The performance test results in mix design showed that the mix had an average, had a Hamburg rod depth of 1.77 millimeter, very decent, and an FI of 11.8 using binder source B at the design. However, later in the production, we switched the binder source to another source, A, across the whole production. And later during the off season, we gathered the raw materials and ran the lab verification on the same design using binder source A. And we found that the mix with binder source A actually gave a much lower flexibility index compared to the binder source B. At that time, we also checked the CT index of the mix, which turned out to be 57.6. Here's a quick overview of the production acceptance test result from V-Trans. Overall, on the Hamburg side, the mix had an average rod depth of 3.6 millimeter, and no stripping inflection point was identified. And on the IFES side, the mix had an average of 15.4. And the quality levels calculated in the PWL specification were 100% for all the mixes across the production. During the production, we worked very closely with V-Trans on split sampling the mixes across all 9 lots, and also work with them about the results comparison. V-Trans completed their test first, and we strictly followed their practice, including the sample reheating and sample fabrication to minimize the variability on the sample preparation process. And here are the comparison of the Hamburg rod depth between us and the agency numbers. V-Trans numbers are represented by the blue bars, and our numbers are represented by the orange bars. As you can see, our numbers line up very well with agency's numbers. And V-Trans got an average of 3.62, and we got an average of 3.51, very close. And the variation of the mix across all 9 lots through the production represented by the standard deviation in this table for V-Trans and us were also close, with V-Trans getting a 0.69 and we got a 0.72. Let's take a look at the IFET comparison. So the majority of the data from either V-Trans or us actually passed the spec limit of 10, except for a couple borderline values from us. And V-Trans got an average of 15.5, and we got an average of 12.5, which seems to be lower than V-Trans. And later, the further statistical analysis also showed that there was a significant difference between V-Trans number and our numbers, which probably can be directly seen from the figure that V-Trans got a consistently higher number than us. Other than that, the variation across the production represented by the standard deviation for both us and V-Trans numbers still close, around 2. And the repeatability of the test, this test conducted by V-Trans and us look pretty good overall, with an average coefficient of variation of 18%. Some of you probably have noticed that there's a significant difference between the production numbers and the design numbers. Here's a quick overview and direct comparison of the performance test results between the production mix and the design mix. So you can see from the table that on the rodding side, the rod depth out of the production mix gave a much higher value compared to the design mix, almost double. And on the cracking test side, both cracking tests, the IFET and the ideal CT on the production mix actually yielded a much higher number compared to the design number as well. it seems that the production, at least out of this pilot study, tends to be softer than the design mix. And in order to further verify this trend, we dig into the database, the mixed performance test database shared by VTrans, and identified all the mixes that share the same mix design as the pilot project that we produced in 2019 and 2020 season. And here's what we found out of the IFIT numbers. The design number is represented by the red horizontal line, which is 5.5, if you recall. And all 13 mixes that we were able to find all have values higher than, out of production, all have values higher than 5.5, which was a design number. In fact, there are many factors in the production actually that can affect the mixed performance test result, such as the aging condition, which includes the silo, which is related to the silo condition and also the silo storage time. The production variation, specifically on the AC content and 200s, the switchover of the asphalt binder source, the aggregate property change, and even the wrap source change. And all these factors can affect the BMD test results. I want to specifically talk a little more about the impact of asphalt binder source, as switching the binder source is pretty common among the paving contractors, depending on the availability and the cost of the materials. However, unlike the super volumetric design, the balance mix design test result could be very different if a different binder source is used. So in this figure, location number 2 is where the mix for the pilot project were produced. At that location, the nice aggregates are primarily used. As you recall that the binder source A, which was used in the design verification, yielded a much lower FI value compared to the binder source B. Something even more interesting that we found later is when we took the same binders from these two sources and ran another verification at a different location where the limestone aggregates were primarily used, we noticed the ranking was completely reversed. And this time, the binder source A actually gave a higher FI values than source B. So this tells us that there may not be a consistent trend when evaluating the impact of asphalt binder source across different locations. As aggregate source could also matter, caused by the aggregate surface chemistry, the aggregate absorption, and other physical and chemical aggregate binder interface properties. All these could have an impact on the BMD test result. And such compatibility between the asphalt binder and the aggregates also needs to be considered during the BMD evaluation. Quick wrap up of the lesson that we learned out of this study. First, the interlaboratory variability needs to be better understood. As we found, our Hamburg numbers line up pretty well with the agency numbers. However, there's a significant difference between our numbers and agency numbers on the IFIT. And Aaron has just mentioned that round robin is on the table in Vermont, and we look forward to working with the agency on that. The performance test result out of production mix could be very different than the design mix. And we need to look further into this and doing further investigation to see if it is mainly because of aging or other factors. Also, binder source could have significant impact on the cracking test results, which has already been noticed by many agencies and contractors, I believe. It should also be noted that the ranking of the different asphalt binder source could also be different at different locations due to the different aggregate sources you used. Because aggregate source also matter during the BMD evaluation. Some additional thoughts say, if the mix performance is not balanced or does not meet the specification, what can we do to improve? Adjust the AC content. Seems very straightforward and always one of the first things that come into our mind. Adjust the wrap percent, which is typically very effective in improving the cracking test result, although it may drive up the mix cost. Changing the virgin binder grade, especially bumping up the binder grade and making the liquid stiffer, could be very effective in improving the hamburger or running test result. Adjust the aggregate gradation. I've heard stories from others that by switching from fine gradation to coarse gradation, their cracking test result got significantly improved. Use the help of additives such as recycling agent. Actually, there were a lot of good discussion at AAPT meetings about the use of rejuvenator or recycling agent. And with the further implementation of BMD and also better understanding of this type of product, I believe there could be opportunity between the paving industry and also the agencies to further look at this opportunity. Changing the virgin binder source, which has already been covered by my previous slide, as the binder source could have an impact. Now also changing the aggregate source seems to be challenging most of the time. However, this could still be an option at some remote locations where hauling the aggregates would be necessary anyway. And many more, I'm sure, from others' experience. Next steps for us. First of all, we're continuing benchmarking work and working with agency on the split sample testing, the round robin study, the data sharing, and also further discussion on the specification development. We will also continue our in-house evaluation on the mix out of both design and production. As I mentioned earlier, running the test isn't usually hard. However, it takes time to really understand the data and the implications behind. One of the things that we've been doing is to analyze the mixed data by correlating the different performance test results with the different mix parameters and try to identify the most significant factors affecting those performance test results. Once those factors are identified, regression models can be drawn and established in order to guide the mix design adjustment. We've also been trying to stay ahead of the curve by allocating resources on some internal studies, such as evaluating the impact of production variation on the BMD test result, selecting a proper long-term aging protocol for the cracking test, proposing different versions of performance designs according to approach D, among many others. That's all I have. I'd like to thank you all for listening, and I look forward to further discussion with you all in a couple hours. Thank you.
All right, excellent. Thanks, Chang. So now we'll move on to our second state, starting with the state DOT or agency experience, and we'll move on to Virginia. So our next speaker is going to be Stacy Diefendorfer. She is the Senior Research Scientist at VTRC, Virginia Transportation Research Council, which is the research arm of Virginia DOT, where she has 24 years of experience, 17 of which at VTRC. So everyone welcome Stacy.
Hi, everybody. Good afternoon. Hopefully we're moving right on through the afternoon and lunch is not setting in too much. I'm Stacy Diefendorfer. I'm with VTRC, and I'm talking a little bit about the Virginia perspective on BMD. I don't have an acknowledgement slide because, quite frankly, I don't think there's enough space in a presentation for the acknowledgements. We've been working with BMD for since 2016, 2017. And it's the sort of effort that half the DOT is involved. Most of our industry is involved in some form or fashion. So I just want to say to the folks that are out there virtual and the handful that are here in person, we appreciate it. I mean, this has been a very, rewarding experience. The primary motivation for VDOT looking at balanced mix design is lifespan of our pavement. When we moved to super pave from Marshall mix design in the late 90s, early 2000s, we replaced the issue of rutting with cracking. And so the pendulum swung a little too far the wrong way or the other way. So our goal here is to go back and rebalance our mixes and improve our durability. Some of the benefits that we think this will have, to be able to use tests that actually relate better to performance. We know volumetrics can indicate a good or bad mix, but we also know that we've seen mixes with perfectly adequate volumetrics and perfectly terrible performance. We want to be able to look at performance-related tests that we can run during production. We know that production is not controlled by something like a performance-related test. We're back to volumetrics for control, but if we can keep monitoring that performance, we can catch things before they get on the road or shortly thereafter. And we're interested in the use of innovation, whether it's RAP that has been driving in a lot of the urban areas of the state, looking at rejuvenators for both RAP mixes and higher RAP content mixes and lower RAP content mixes. Whatever else it might be. We've looked at fibers, we've looked at other softeners and additives. Anything that we can use to extend the life of the pavement is beneficial to the DOT. And the best thing about it is if we can work with our industry, be innovative, think outside the box, all those good cliches, we both benefit. And that's really the way that we need to move forward. As I said, we want to try to balance rutting and cracking. Our mixes were in that lower left-hand side, being somewhat crack susceptible, but more rut resistant. And we're trying to move that cracking resistance and improve it. We use the APA test for rutting, and we're looking at the IDT-CT, ideal CT test for cracking. I'll talk about that more in a minute. Looking at our implementation, this timeline was put together. We had been working to talk to the central office materials folks, our operational folks, and really as a research group, our clients about moving towards this and looking into doing balanced mix design. And interestingly, they took off with it and gave us about a 5-year timeline and said, we will be implementing this, which is exciting. Hey, they bought in, we're all in this together, and 5 years. You think we're going to be ready to roll this out in 5 years? No small amount of pressure. So what we've been doing is we started off with our research side, looking at laboratory tests, the criteria that we want to use, and starting to develop an initial test specification. In 2019, we started with some pilot projects. 2019 and 2020, we've been, as a state, we've been into lab equipment acquisition. When we started this, our research lab was the only lab with the rutting test capability. Our field labs had the ability to do an IDT test in terms of TSR, but had to be upgraded in order to be able to do the full measurements to do the CT index. And some of our labs were also using a Cantabro test. Some of our labs didn't have LA abrasion. So we've been working through, and you can see that timeline's almost a year for that. Being a DOT, the red tape is not insignificant. We've been looking at developing and executing training. Just this year, we started to do some just-in-time training for both the DOT and the industry. We're in the process of refining those specification requirements. We know that what we came up with a couple of years ago as an initial stab is exactly that, an initial stab. As we get more field information in and we can start relating that performance that we're getting out of mixes that we have test results for back to those values, we can fine tune the specification. And we're looking at 2023 for initial implementation. Now, initial implementation may not be statewide, every single mix. That's still somewhat up in the air. But what we're primarily looking at right now is our maintenance surface mixes. We do a lot of maintenance paving, overlays, mill and fills, and starting to apply this to those. Over the long term, it's likely that there would be different classes. You know, it may not be worth doing the effort of a balanced mix design for a rural route with minimal traffic. But at this time, we want to get the experience, both with the designs, with the testing, and with the mixes themselves. So they're, at this point, they're kind of being put everywhere. So what approaches are we using? At this point, we start with volumetrics and end with performance. And I think that makes sense on a lot of levels. It's a comfort level. If you tell somebody, here's an asphalt content, and you say, well, you know, I'm going to use 7% asphalt in my mix, somebody's going to look at you and go, and exactly what mix is that? You know, and it's either going to make sense or it's not in context. We can start off by working within our existing specs, as we do all of our acceptance on volumetrics. Along with that comfort, it's kind of a risk mitigation. As we're looking at new designs, you know, that sense of, is that a reasonable mix based on volumetrics? You could say yes or no and kind of assess what is the risk moving forward. And let's face it, it's practical for production adjustments. You know, I wish we had a switch on plants that says cracking resistance increase. Let me know if you have any ideas. Maybe we can work together. But until then, you know, we're controlling by gradation and AC and our source stockpiles. So we're trying to make this practical. We're dealing with two types of mix types so far. What we call a performance plus volumetrics, or a P plus V mix. That's basically the AASHTO type A mix. We must meet volumetric and gradation requirements in our specifications, section 211, and the performance requirements that we outline in our special provision. So basically, you know, it's a performance tacked on to your volumetric mix design. And it's worked pretty well so far. I mean, we've been able to put down a lot of projects working off of a baseline mix and then adding that performance to it. But we think we can go further. What we're calling these are performance optimized, or a P mix. It's not quite a D, the method D from AASHTO, but it's a little more than method C. The mix can be designed however you wish. Most folks are starting with volumetric design for obvious reasons, but you must meet the performance requirements. That is your primary concern. We waive the volumetric and gradation requirements for that design. However, once you submit the mix design and go into production, your production tolerances that are outlined in the specifications transfer to your mix design. You can design whatever you want, but you have to produce it consistently. And so it's kind of a meet in the middle way to address this, because we want to be able to measure consistency, and volumetrics is the most straightforward way that we can do that at this point. This just seems to make sense to us. Test selection and spec development. The way that we've approached that, we've benchmarked current mixed performance properties. We started doing this a few years ago on some mixes that we had from 2015. Use that to set our target parameters. The idea is that we'll use those parameters, evaluate the design, adjust your design as needed. And then during production and construction, if we need to go back and reassess and make tweaks during production to get that mix back where it needs to be as it goes through the plant, you know, the big thing that we're looking at is long-term validation. That's the step that's missing. Matching those results, the performance-related test results, to the mixed performance in the field. And the truth of the matter is, most of the tests that we're using and the way that we're using them, they haven't been around long enough for us to have significant field. The only way that we're able to have data going back to 2015, we had a very large project then when VDOT was changing some specs. We sampled heavily, we noted the sections we were coring and doing a lot of evaluation on those sections. And we sampled a lot of mix and had extra mix. So that as things like this, the ideal CT test came along, we were able to say, okay, we have this mix that's been in storage, stored properly, closed boxes, the whole 9 yards. And now we can use it and try to start with these newer tests. And now we're at least 2 or 3 years ahead of where we would be if we were sampling this year to start testing. So we used 11 mixtures in 2015. These were all highly characterized, everything volumetrics. We were doing dynamic modulus. All of the, basically we threw the lab at it. And we got a reasonably well-stocked lab. So there was a lot of testing on it. What we were looking at specifically with relative to balanced mix design were evaluating our volumetrics. We looked at the Cantabro test as just kind of a go, no go general durability test. We were really primarily concerned with cracking. We looked at the ideal CT, Inflex, iFit, and the overlay test. As we had used the overlay test a little bit for prior work, the ideal CT, Inflex, and iFit we had the ability to run them, and I don't want to say they're variations on a theme, but they're all an indirect tensile type test. And we are an APA state, so we were continuing looking at the APA. And the idea was to select a test, benchmark everything, and then select a test based on some of our criteria. We looked at repeatability and reproducibility. Were the results repeatable across each mix? Were they something that we expected somewhat? In those mixes that we evaluated, we had a PG 76 -22 mix at the time. We had 64 -22s. We had various wrap contents. Did things make sense? One big consideration that, depending on who you talk to, may be good or bad, we were very concerned with ease of use. The idea with our implementation is that these will be production tests. It has to be practical for production testing for that. We cannot have a 36-hour test preparation requirement and turn it around. That's just not realistic. There's too much asphalt out there on the road by the time we get the test result back to do anything with. Availability and cost. We have to be able to get the tests. The industry has to be able to get the tests, and it has to be something that mutually we're both willing to afford. Sensitivity to the mixed properties. You can get reasonable data back, but if the data seems pretty random relative to, say, asphalt content or air voids, your binder type, the test is not going to give you good information. And that requires some validation. That's been ongoing. And correlation to field performance. I mean, in the end, even if we find that one of our tests that we've selected is fabulous, if we can't get a good correlation to the field, we're going to go back to square one and start over. Setting criteria. From those 2015 mixes for the APA, we looked at our maximum benchmark value. The rationale behind this, we didn't have general rutting issues. We would have intersection rutting from heavy loads and the occasional issue with a binder or with a mix that went out that had some inherent problems that had nothing to do with anything else. So we said of those mixes, if they didn't have rutting issues, why should we kick them out for a rutting criteria? For durability with Cantabro, again, we didn't really have any consensus issues. We don't specifically have a lot of stripping. We happen to be an anti-strip state. So stripping and raveling is not terribly common in the surface mixes in particular. So we looked at our maximum value and said, these mixes are typical. We would expect typical performance, which is pretty good. We probably shouldn't kick them out. And the values that we looked at were similar to those in the literature from other studies. For cracking, we selected the IDT-CT or ideal CT test. We took the average value for this test. What we decided is cracking is our primary failure mechanism. Now, whether that be fatigue cracking, surface cracking, you could be arguing whether it's top down, bottom up, side to side at this point, but the end result is our mixes crack. And so since that was our failure mechanism, we wanted to be conservative. So we took an average value wherein we assumed that approximately half of our mixes should perform reasonably well. Half of them probably were not. And we took the average value of the CT index results from all of those mixes. Additionally, that value happened. Interestingly enough, we have Turner Fairbanks in our backyard, which is fantastic. And they had been doing some ALF work looking at the CT index. And even more conveniently, a lot of our local Virginia contractors, they're the ones that pave the ALF. And even better, sometimes it's based on Virginia style mixes. So we had a nice little capability to look. They weren't exactly matched up, but we indicated that at about the CT index of 70, mixes that had a higher CT index, the couple that there were, they seemed to perform better. Those that were lower performed less well. It lined up reasonably with what we were looking at with our handful of example mixes, and helped us say that, we thought that decision for now was the right one. To validate those numbers, we went back out the next year, 2018, 13 evaluated mixes. 6 that we went out in the field and sampled, 9.5 and 12.5 millimeter mixes from across 4 districts, and 7 that industry sampled for us, 9.5 and 12.5 mixes across 4 districts. We were trying to get good coverage across the state. For those, we ran all of the testing and we compared it to what our criteria were. For rutting, we're looking at 8 millimeters maximum. Our test temperature is 64. Virginia has not had the best experience with APA because our prior temperature was 49, and nothing cracks at 49 degrees in Virginia. Ruts, sorry, not cracks, ruts. Cantabro, we're testing at 25C, mass loss less than 7.5%. And CT index, we're testing again at 25C. The index needs to be greater than or equal to 70. In the process of doing this, the Cantabro and APA during design are aged for 2 hours, and the CT index is for 4 hours aging in accordance with it being a performance type test. So 2021, this has been kind of gaining speed. In 2019 and 2020, we did field performance trials, and we partnered with various contractors to put out control mixes and balanced mix design mixes. Some were lower wrap content, 20 to 30%, which is our typical range for surface mixes. We also did some 40% wrap. We used control mixes. We looked at binder dumping and dropped to a 58 minus 28. And then we looked at various recycling agents. Based off of that experience, we've put together more of a, I guess you would call it more of an actual production type special provision. And in 2021, these were advertised on specific routes within our maintenance schedules within districts. They were approximately, the control mix that was paired with it was somewhere between 2,000, 4,000, 5,000 tons. And then the BMD mixes were anywhere from, I'm trying to think, about 2,500 to 9,000 tons on specific routes that were selected so that the control mix should be in a comparable position to the BMD mixes for future comparison. We advertise these as either the performance plus volumetric mixes that had to meet those requirements and meet the performance, or the performance only mixes that must only meet the nominal max. Gradation and volumetrics were waived, but those production tolerances were applied to the JMF. So in addition to this, we had 2 special provisions. This gets more complicated. And we apply 1 special provision to mixes with wrap contents of 30% and below. What that allows, those are our typical mixes. As we've been looking at higher wrap contents and trying to get more recycle used, we have a special provision that accounts for above 30%. Typically, we're looking at 35 to 40% so far, just due to some of its supplies, some of its wrap quality, and some of its plant capability. For this year, our production testing QC, in Virginia, the contractor takes care of all QC QA. VDOT goes in and handles the independent monitoring and validation. We work off of a 4,000 ton lot. For these jobs, the testing could be applied to a 2,000 ton lot as needed. QC performance test results were due in 2 weeks, if at all possible. Sometimes that's happened and sometimes it hasn't from this season. And this season, when we've been doing this, quite frankly, over half of the producers that got these scheduled contracts had not worked with us on a BMD. This was their first state experience. Some of them had been working quietly on private work or in the lab over the holidays. But as far as for working with VDOT on them, it was showtime. QC testing is using stratified random samples every 500 tons for the AC and gradation. Volumetric and performance testing were done every 1,000 tons. From the producer side, this was 5 CT pills and 3 Cantabro pills. We did not ask any producers to run APA ruts testing on their side because of the equipment issue. Independent monitoring, the IA program was every 2,000 tons, basically at the time of the volumetric IA testing. For those samples, the contractor prepared their IDT CT pills and Cantabro pills, and then they also prepared the VDOT pills. So double the workload. In addition, they would prepare the APA rut pills that we would test. This year, we collected 6 boxes of loose mix for research purposes to look at. We're going to go back, we're going to reheat those mixes. We're going to be looking at all the performance values on reheat mix. And in some districts, for some projects, the agency collected extra mix to take back to our district labs so that they could gain more experience. It's a lot. And a few people are like, yes, no big deal. You know, this is worthwhile. I will say I have kind of been chewed out, to put it mildly, because some folks were really not expecting what it would involve. But that being said, after a few days of this, and doing this every 2,000 tons was purposefully spreading it out for the VDOT samples so that we were trying not to overwhelm anybody. To be honest, we paved our HVS last summer with BMD mixes, and we ran 4 samples per day. And basically paving depended on the lab and how fast we could get the samples done. So we figured, you know, you could throw everything at it to do that. You know, a sample every day or 2 was not going to kill anybody. And we'd had feedback we have a lot of collaborative meetings with industry and VDOT. And we try to get everybody in the room that has experience so that the spec is realistic. Challenges for implementing this. Well, there's a lot of things we don't know. Hopefully we have the right tests. That's kind of the first assumption we're making right now. And hopefully we have criteria that are somewhere near where it's supposed to be. But it also, you know, what happens as the material changes, as you work through a stockpile, as the wrap changes somewhat, as you just go through the plant. We know that lab mix and plant mix are 2 different things. We do have some folks that design through the plant. They said that was an interesting way to attack it, and they were less surprised at the end. You know, just different philosophies. So how do we make mix adjustments? If we find out that we're going through and our AC goes up, well, we have an idea what that'll do to performance testing, but when we adjust it down, how much is enough? How much is too much? What sort of natural variability throws us out on the performance side? That's some things that we're looking into through some various projects. The reheated material issue is going to be a plague of DOTs everywhere. We, like probably everyone else, we collect at the plant. We collect at another plant. You know, the guys are out on the road all day collecting mix, return at the end of the day, gets reheated the next day, and all of the testing performed. Unless they're lucky enough that the plant's right down the road from the lab and then they swing through and drop it off. So we're doing reheated mix testing on everything. Do we need unique target values? Do we design with one value, run our mix through the plant, and then determine our plant target value? How are we going to deal with that? As we're doing QA/IA, how do we compare the contractor QA values that are on plant material that is unreheated to a VDOT value that is reheated? They're not going to be equivalent. How do we account for that to look and make sure that we have that independent assurance? So we're trying to tackle that. The additional effort in testing, and I think this definitely hits the industry as well as VDOT, manpower and time. We lack both. Getting equipment, we're lucky that we've been able to outfit all of our district labs. We have 9 districts and 7 labs, and every lab is now up and has the ability to run. There are a few that are dragging their feet a bit. But there's complaints from the labs that, we're already busy just doing volumetric testing. How do you expect to add this extra workload on us? We're going to have to deal with achieving more manpower and training. The big thing is training. We thought going into this, particularly with the CT index, everybody runs a TSR. This is not difficult. We did a round robin last year. The first stage of the round robin, we provided the samples and we asked people to run an IDT CT and send us results. And some labs that should theoretically be very capable, you're running a dry room temperature IDT test. They couldn't or didn't, or some of it was machine issues, equipment issues. Some of it was just not knowing what to look for, not knowing what to do. And so we found that we really need to up our game in terms of training and qualifications for those running the tests. This year we ran some just-in-time training. We've been trying to have folks go around. Industry's been, the Asphalt Association has been going around and trying to offer some training and assistance. But it's one of those things we're going to end up needing to certify our technicians and our mix designers to know what to do to make sure that we're consistent. We're just getting the data analyzed from the second round of our round robin where labs made their own pills. So I'm waiting to see how that variability comes out. We know the variability will go up, but how much? The challenging tasks, initially agency and industry buy-in. I think as we've all realized that this is a mutually beneficial opportunity, more and more people get on board. The folks that are forward thinking and that say, this is how business is today, but we know it's going to change in the next 2, 5, 10 years, are eager to start looking at this in more and get it out even faster because we've got opportunities to do things differently and we've got opportunities to do things better. Figuring out the testing, field verification, the lack of precision and bias statements we're working on, the reheat, non-reheat differences, looking at the training, making sure everybody follows the same test procedures. I think what happened when SuperPave came out, there was a huge push for training because we were doing different things. And we were looking at them differently. And I think we've gotten a little lax. Everybody knows how to bulk a pill, but everybody knows how to bulk a pill slightly differently. That gives you a slightly different result. We need to get back into step, and work like that, smoothly coordinated machine that everybody does it the same way, not just their way. Addressing aging is a big concern. There's lots and lots and lots of aging protocols being suggested, but how do we know what's the right one? And more as importantly as how do we know what's the right one, what right one will work not just for research, but for actual design and production. And again, the equipment procurement and manpower have been a big issue. And that wraps up the VDOT side.
All right, thank you, Stacy. And then our last presentation before break will be the Virginia Contractor experience. So we have with us Danny Poole. He's the Director of Quality Assurance for Superior Paving Corporation, where he has 35 years of experience in the industry, 30 years with Superior Paving. So let's welcome Danny to the stage.
Thank you, Derek. I do have some acknowledgements I like to make. I don't have a slide for that, but big shout out to Stacy and her team. We've been part of some pilots in 2019 and 2020, and she did a lot of traveling, a lot of night work, and it was a tremendous amount of work. So thanks to her and her team. I'd like to thank also Dave Shields from Northern Virginia VDOT for their cooperation to allow us to do these trials, and also Kwame Adu in the Fredericksburg district for allowing us to do that work in that area. Also, two of our aggregate suppliers, Falcon Materials and our biggest supplier, Luckstone. I tell you what, they've been over backwards for us to come up with different innovations and aggregate changes to help us be successful. So it's usually a big deal. As stated, I got 35 years of experience, but I got about 35 minutes experience of doing this type stuff. So I apologize in advance for any awkward moments of silence. I hope everyone in this room enjoyed their time in Nashville. Myself, not being a fan of country music, I went to the Music Row yesterday and had a blast, but it certainly did not influence my taste of music. So anyhow, I think this thing's moving too quick on me. So just to get started and share our experiences, conversations first started that I'm aware of in 2017 through 2018 about doing something different. So in 2018, the BMD Technical Subcommittee was formed, and I was fortunate to be a part of that. Personnel from Virginia DOT and the Virginia Asphalt Association, and some of us contractors. It was probably a team of 18 or 20 people. And I tell you what came out of that kickoff meeting, everyone was in agreement that there is a definite need for a different approach in designing and producing asphalt to help combat our cracking issue. I drive a lot of roads in the northern and central Virginia area, and I tell you what, seeing some of those cracked pavements out there does disturb me. It does bother me. So to be with a group of people that are as anxious as I am to do something about it, it's pretty rewarding. So out of that meeting, some of the discussions that were included was what test to use. The cracking test, Stacy touched on it. It was decided before this kickoff meeting that we would look at the ideal CT. In various studies, to my knowledge, it was found that it was also correlated very well with some of the semicircular bend and simple shear test. And also it yielded quicker results, quicker turnaround. And it can be used as a quality control test. And it was far, far less complex than a lot of the other tests that were out there. And certainly something for the contractors, especially us with having 10 plants, it was more affordable when it came to equipment. Speaking of equipment, well, let me continue with the Cantabro. The Cantabro thought as a binder check durability. We ran a lot of those. We borrowed one. We borrowed an LA abrasion. And I'm just now telling Alicia this. We borrowed one from Luckstone and it did break. Should have told you earlier, but the flight inside of it fell out. So we purchased one. We purchased a different brand and it also broke. So they're very expensive. We talked to the manufacturer. So if anybody out there is going to eventually buy a LA abrasion, it's something you might want to think about. I don't know if they were designed to take that pounding from those asphalt specimens. As Stacy touched on, we have not purchased an APA machine yet. We have evaluated some of our mixes, a lot of them that a research council did for a job mix verification for us. And we sent some to a third party lab to have some results done for us. I haven't seen any rutting in Virginia, especially the part of the state that I'm very familiar with in a number of years. So that kind of gives me some hope and some promise that we can really, really do something going forward in increasing our numbers on our ideal CT numbers and making a huge improvement on these mixes. So maybe we're quite a ways from getting back to the rutting issues we had years ago. The equipment, I tell you what, there's just as many as equipment manufacturers out there and models as there were cracking tests on the table. We haven't made any huge investments in purchases of equipment yet. We purchased enough to satisfy our 10 facilities and where we can transport specimens up and down the road. I'm really anxious to hear the round robin that Research Council did using various equipment types and brands and see how those numbers compare. Discussions also include the type mixes. You know, right now we're concentrating on the 9.5 and 12.5 sampling frequencies, procedures, test methods, and pilot programs. So speaking of criteria, as Stacy touched on, the ideal CT value was equal or greater than 70. So not counting any of our low wrap mixes where I work or virgin mixes, our allowable VDOT 30% mixes, that puts us about 20 surface mixes that we're evaluating in-house. And I tell you what, we're feeling pretty comfortable with the 70 value. And I've had conversations with people, some of within this room today, is 70 the really right value for production through the plant? You know, to me, I don't know if I'm completely sold on that because maybe it needs to be higher. I know during mix design on the 4-hour aging, the short-term aging, our values are similar, but they are less. But they're more close to the 70 range than what we're seeing now through production. And what really excited me about jumping on board on this, we get to look at all our mixes. And so we have seen right off the bat where 2 of our mixes needed addressing pretty quickly. And I know I'm jumping ahead here. The Cantabro, let me just jump back with that. We've run a great deal of those Cantabro tests. To me, right now, it doesn't really seem too concerning with our mixes. But in the past, we ran a lot of Cantabro tests on porous mixes and how sensitive that test is to a variant. I mean, within a tenth, 2 tenths, 3 tenths of binder. I mean, it was a great spread, a big difference in binder content on those results. So we really pay attention to the Cantabro when we're doing the porous mixes. Also, we learned the hard way when running these Cantabros, it's probably a good idea to have this LA abrasion machine in a climate controlled atmosphere rather than outside or in a shed with no heat. And when you're running that test and the specimens are very, very cold, it yields you great loss. So we kind of learned the hard way on that. Again, the APA running is equal to or less than 8 millimeters. And at this moment, we feel pretty good about that. Pilot projects, we participated in 3 of them. 1 in 2019, 2 in 2020. Different locations, 3 different plants, all of them at 40% wrap. And varying aggregates, a lot of different varieties in aggregates. I'm talking GSBs of aggregate anywhere between 2.7 and 3. And those 2 mixes I have on there, I'm going to talk about what we did. Those 2 of those mixes needed some immediate attention. And the 9.5. The one that this 9.5 mix we were going to do in our Fredericksburg district, even though it met all current specifications in section 211, all the volumetric gradation bands and everything, it was a great mix on paper, but the performance values were really bad. So talking to Kwame and Stacy, we all agreed that we pull the plug on it and maybe do it next year. So it really gave us an opportunity to make a change in that mix very quickly, in which we did. And in that 9.5 mix, we have, of course, wrap, and we have 2 washed 10 products and a number 8 stone. The difference in the gradation is similar in those two products, but the FAA defined aggregate angularity in those two products are huge. It's a big, big difference. Unfortunately for us, the product that was going to, bring better quality to our mix was the one we had to import. So we ended up importing, well, we were importing this product, but now we got to use a lot more of it. And it created VMA. It increased our binder content, and the ideal values really, really seen a difference. I mean, they really, really increased. The 12.5 is still being addressed at this moment. It's kind of on a borderline. We're not comfortable with it. So I'm having conversations with our aggregate supplier at this moment on the number 78 stone. The flat and elongated on the 3-to-1 ratio is currently at a 6.4, which is a great product if you're running SMA. If we can change that particle shape, like I say, we worked with it, the gradations are still similar, and we can get that F&E to a 17.6. Again, it allows us to increase the VMA to allow some extra binder to get into the mix, and we feel really good about where we're going with that. QA, QC operations. It is an increase of workload. I'm part of the subcommittee, and we're looking at all these proposed specifications, testing frequencies and all this stuff. And, when you're in a room like that with a positive people, you're all pumped up. Yeah, let's do it. Then when you get the job and you've got to talk to your folks, and this is what we're going to do, it was a different story. But I tell you what, with a lot of planning, you've got to be very, very well organized in running these pilots. You got to anticipate the next move. Our guys stepped up. They did a great job. It was a lot of work. It was certainly a lot of work, but well worth it. We learned so much. And through accuracy, I feel confident we can predict mixes down the road and extend our pavement life. Volumetric leniencies, and what I mean by that, and I told you I didn't have much experience doing this. I wrote some notes on top of my notes, but through our performance testing and what the tests suggest that our optimum asphalt content should be does not align with current volumetric specifications. It's not true in every case. So once we gain a lot more information, even after 22 and year 23, it's my mindset, it's just my opinion. I don't see us ever going away from volumetric property testing. I can comment on that later, but maybe there's some kind of leniency if our performance tests say that we need more binder. And through all that stuff, I'm confident that we can make a difference. We can actually deliver a better quality product. I want to talk about recycling agents through all our 3 projects. Our pilots, we used a recycling agent on all 3 of them, partnering with 3 different manufacturers. And years ago, when I heard about these rejuvenators, I was a little skeptic. Is this a snake oil or does this stuff really work? But I tell you what, we've had great success with it. We really have. Also, alternate binders. In our studies, we used a 58-28, and we've seen great increases in our ideal values using a softer binder. Disadvantages staying competitive. Some of the things I talked about those other 2 mixes that we need to make addresses on. Are you bringing in different products? I mean, you have to increase your binder. And that's why I'm so excited to work where I'm work at, because we're jumping in with both feet. I mean, we're looking at all our mixes. So when 23 does get here and it's finally spec'd, there's not going to be any any surprises. So to remain competitive, we're finding getting a lot of those answers now. Another disadvantage, and when I put this together a while back, to creating specimens immediately, and this isn't true for all our plants, but we have 4 plants that we, on an average day, we ship anywhere between 2,000 and 5,000 tons a day. And at that sampling frequency, it can get busy, and you got to be creative, and you got to think of the next step. It's challenging sometimes, and so that's why I have additional oven space in there. Some of our labs were slower producing labs, and even the ones that are high producers, we still don't have the oven space when you're pulling those many samples, and additional lab space. Where are you going to put this equipment? It's all things to think about, and could be a disadvantage to a producer. Through our journey so far on improving test results, change in particle shape, I think I put up there with any of them. We learned that, like I say, our ag producers, they changed some of the practices and that they're doing to help us be successful. F&E, fine aggregate angularity, makes a huge difference in what we've seen so far. Changing gradation is certainly a factor as well. It's right up there. Increase in binder is certainly a difference maker. Use of recycling agents. I don't have the values in front of me. That wasn't an intent of my presentation today to go over values, but it's made a believer out of me, and it's certainly helped our numbers. And someone mentioned before the adjusting the feet of your wrap. I don't think we're much interested in feeding less than 30% wrap. So that's why we're exhausting all these different avenues before we cut our feed and wrap. We got more wrap than you can even possibly think about. It's incredible in Northern Virginia, the amount of wrap up there. It's crazy. Looking back, if I would have done anything different, looking back, talked about the 3 pilots that we did 40% wrap in. There's no interest from the department right now to go over 30% wrap. It's shelved for the immediate future. There was a lot of time and effort put into those studies. I mean, a tremendous amount of work. But I don't look at that and say it's all for nothing. It was still good work, it's still good data, and it's still 3 pavements that we can continue to monitor all the time. So it wasn't all for nothing. And I feel confident at some point we'll be looking at higher wraps. I mean, we have a couple plants that are engineered to run high wrap, and the wrap is there, and I'm gonna stay on top of it. Also, looking back, a different approach. If we didn't do the high wraps, maybe we could have done those studies in 2021 or 22 or 23, but that's not the case. But if I could go back and we didn't do those high wraps, I would have certainly focused on varying gradation blends on all our mixes, different aggregate properties. If there's some manipulation we can do with some particle shape, you can't really change the GSBs. They are what they are. And I probably would have collected samples myself and done reheats. It's something we didn't do, and we're going to start doing that. We're doing it this year, and we're going to continue to do it to build our database, our own internal database. I would have looked at different equipment manufacturers. I would have maybe, hey, let us bring in a piece of your equipment. You know, I know it's some extra work, but let's run some ideals on your test clip. Let's run some ideals on the Smart Jig or all the different makes and models out there. That would have been great to look at. Looking forward, moving on. I tell you what, I want to look at the short-term aging. We have immensely, but I want to keep looking at it. The short-term during design process versus production. I certainly want to look at the long-term aging. And I tell you what, I'm going to have to be really creative moving people around to some of our slower plants, hiring more people, moving folks around because it's a 12-hour aging process. And and I want to use rejuvenators. I want to compare control mixes with what we're doing right now with just the anti-strip. I want to use rejuvenators. I want to look at that and all that data. I want to let VDOT see it and get their opinion on it, and I'm not giving up on it. Aggregate blends and different sources, I touched on that already. Training our employees is such a huge deal. We've been doing that. We're going to do more of it from this point through the remainder of this year in one of our labs. It's big enough to have classes in there and to do extensive training. And I've already got dates set out. We're going to do continue to do training. I think the biggest thing I'm looking forward to is our continued partnership with VDOT. It is so huge. I can't say enough about the Research Council and the districts, the 3 districts that we work in. It's just been awesome. Want to continue that partnership, and certainly with the Virginia Asphalt Association. I have no idea how much time I had. I didn't see, Derek standing up, so I'm probably out of time. So that's all I got, folks. Thank you.
All right, everyone, we're going to get started here. I'm going to ask you to take your seats. Keep us on schedule, mostly. So the final state that we'll talk about this afternoon and get the perspectives is New Jersey. And unfortunately, the contractor and DOT people from New Jersey couldn't be with us in person today. So we're going to have a a recorded presentation by the DOT, and then a live virtual presentation by the contractor. So first, we'll start with the recorded one from the DOT. That's given by Stevenson Gainther, and he is the principal engineer in the asphalt testing labs for New Jersey DOT. And given what's going on with the storm headed up that way and everything, he ended up having to record his presentation, and we appreciate him responding so quickly and being able to record it because he was unable to join us live today. So with that, we'll virtually welcome Stevenson's presence and get the video started. So.
Good afternoon, everybody. My name is Stevenson Gainther. I work at the New Jersey Department of Transportation, Bureau of Materials, Asphalt Testing Labs. And today I will be presenting to you New Jersey's experience with balanced mix designs. I apologize for not being able to be there in person and also not to be live presenting this, but we've had, I think my town had about 8 inches of rain. So I am dealing with a lot of flooding issues at my house. So before I start my presentation, I just wanted to give an acknowledgement to Eileen Sheehy, who is the former manager of the Bureau of Materials. A lot of the work we've done with balanced mix design, she was heavily involved with it. And also Tom Bennett at Rutgers, and we had some industry partners as well too. I more so came into the picture 5-6 years ago, where I kind of inherited a lot of this stuff. So a lot of the information I'm giving to you today is I got from Tom and Eileen. So primary motivation for us to use balanced mix designs. Our use of balanced mix design started with SuperPave. SuperPave was completely implemented at NJDOT in early 2001. We started seeing some issues with mixes and realized that SuperPave couldn't help with addressing the observed issues with durability. It was decided to take a look at different ways of doing things to get more longevity out of our pavements. NJDOT first, we started using 125 gyration mixes when SuperPave came out. In the late 1990s, we found that the 125 gyration mixes were not working because they were just very low in asphalt content. We then moved to 100 gyration mixes, And a little under 10 years ago, we reduced it again to 75 gyrations for asphalt mixtures. And that's where we pretty much are right now. We do have some L mixes, but we pretty much are at the M level of compaction. After doing all this, we still didn't see a significant improved durability in these mixes. It was then decided to look at performance testing in an attempt to address the observed distresses. We started developing specialty mixes that were engineered for specific applications. Some of the earlier specialty mixes were reverse engineered from proprietary mixes. They were mixes that performed well, so we developed specifications based on performance testing instead of solely volumetric properties. Tom Benner at Rutgers was able to reverse engineer asphalt mixtures to get the desired performance we were looking for. For example, we like the performance of what a lot of you may know as strata, a reflective crack relief system. Thus, we targeted the strata performance and reverse engineered specs to get what we wanted for our version of that asphalt mixture. That mix is today what we call brick. A similar process we did for BWSC. HBTO, BRBC, HIRAP, HRAP are some of the other performance mixes that we also have as well. And each of those has their own specific application. So in summary, our motivations for the use of balanced mix design was because the implementation of SuperPave resulted in drier, coarser mixes. To address the issue, we used lower gyrations and supplemented with performance testing for these specialty mixes to get the level of performance we were looking for. Performance test selected. So early on, there was no effective and quick means to test asphalt mixture for performance. The flexural beam fatigue, SST, IDT were all available, but did not provide an easy and efficient way to test for durability. When the overlay tester came around, that changed things since it can be done on field cores and lab specimens. TTI showed that the overlay tester was sensitive to mixed parameters, which was of importance to us. Today, we have 3 performance tests that we use. The overlay tester according to NJDOT B10, which is on the bottom left there, the asphalt pavement analyzer according to AASHTO T340, which is on the bottom right, and then the flexural beam fatigue AASHTO T321, which is up top there. So the factors in selecting our performance tests that were considered were sensitivity to material parameters, good correlation to field data, testing time, pass-fail tests, and simple analysis of results. The APA and overlay tester met all this criteria. The flexural beam fatigue does not. It does not have a simple analysis of the results, but we don't test a lot of this typically during the season. So we're still able to analyze the results in a timely manner and get it done. So that's why we still use the flexural beam fatigue. Also, we use it on our BDWSC, that's our bridge deck overlay. And we're concerned about when a crack would start. You know, we want to try to resist that crack starting for as long as possible. So a crack initiation test like the flexural beam fatigue is crucial for the performance of that mix. Out of all of those factors, the most important one is good correlation to field data. For the APA, the criteria was set by testing existing pavements that did not have running problems. So in the early 2000s, Rutgers tested a lot of good erupt performing pavements and found that they had rutting in the APA at most of 4 millimeters. So it was determined by Eileen at the time that and most likely Tom, that a good performing pavement for the rut parameter would need to have its APA criteria set around 4 millimeters, depending on its application and depth in the pavement for New Jersey. For the overlay tester, the verification of the criteria was not done until the development of the high wrap spec. SPS 5 sections with various pavements containing different wrap contents were tested and validated that the overlay tester was better than the flexural beam fatigue at determining how quickly pavements fail based off of cracking. SPS 5 sections were going out of service, and we got cores out of the sections and correlated overlay tests to those sections. The sections had a combination of wrap and virgin mixes. The overlay tester was found to be a good discriminatory test to how well an asphalt mix can resist cracks. Once a crack starts, it was able to determine how well a mix resisted that cracking and led to its eventual failure. The next few slides kind of show exactly what I am talking about with the overlay tester. So this was on the SPS 5 sections, and this was showing the transverse and alligator cracking. And I'm not sure how well you guys can see it, but there are 4 different mixes, 2 virgin mixes, 1 milled, one not milled, and 2 30% wrap mixes, 1 milled, 1 with no milling. All these sections at about 2 years showed that there was cracking. So with the crack initiation test, like our flexural beam fatigue, it would show that these pavements all perform very similarly. But we already know based off of our experience that, that is not the case, and that we should see better performance out of the virgin mixes than we do the wrap mixes. So this next slide shows exactly that. If you look at the black line at the bottom, that has the best performance. That's the virgin mix that was milled. And then the next best performing mix as far as cracking goes is the other milled mix, which is the green line. And that's with the other virgin mix with no milling. The two wrap mixes showed alligator cracking almost double or more than double actually of the virgin mixes, which would make sense. Now, with that previous slide I showed you, our crack initiation test, like the flexural beam fatigue, would have showed that these pavements perform very similarly. But in fact, looking at this, the cracks actually propagated very differently through these mixes. The overlay tester was also able to pick up these differences in those mixes. So if you look on the left side, the 2 on the left side are the virgin mixes. The left hand side of the left 2 is loose mix. Then we have field cores of virgin mixes, and then we have loose mix and field cores of 30% wrap mixes. And the overlay test results for the loose mix and the field cores way outperformed their counterparts with wrap, which gave us enough confidence to say that, the overlay tester is able to determine different mixes, different cracking in mixes, and it went hand in hand with the previous slide. So now we have test selected. We feel confident about the criteria that was set, and it's time to put this on projects. The first year, there were 2 HEPTO projects, one on I-95 and I-287. Both are interstate roads with high volumes and very high truck traffic. We were having frequent group discussions to discuss and come up with ideas, and Rutgers executed the plan. An important thing is that there was no constraint on methodology. Tom Bennett at Rutgers was very open to things for us and doing things for us without having to wait for the research bureau for a project. This resulted in not a lot of reports, but more so presentations. Going through the research process would have been very expensive and time consuming. The informal structure allowed for creativity and a lot of trust. Partnership with academia and industry with flexibility and limited constraints really attributed to our success in getting these performance mixes out to construction quickly. The idea with using Hepto on this road was if it was going to work on the high volume roads, I-295 and 287, if it was going to work that on these roads, it was going to work everywhere else throughout the state. We weren't getting the performance with conventional materials used in that area. So we used our Hepto mix, which is a thin 1 inch high performance mix with a PG 64E minus 22 binder. It's pretty much a nominal size 4.75 mix. And we decided we would use it here to see if we can get better performance out of this area. We ensured that we had trusted industry partners to work with to make sure this first mix was produced and placed correctly, which I think was very important. If we had some contractors that maybe weren't the best or didn't care for this to really work, then everything could have been completely different with this project. But we made sure we had a contractor that was a well-performing contractor, and they were part of a lot of the discussions we had. We felt we needed to have a certain level of confidence with the supplier and contractor on this project because we were doing it on a high-profile road. We couldn't have done this also without the support, of Rutgers. So for Hepto, the first project ended up being very successful, and I think it was because of a lot of that partnership and just having that trust in one another. For BDWIC, there was one pilot project in Atlantic City because it was a reverse engineered mix. And that was from, I think it was Asphalt 50, I think it was called. We had confidence that it would perform very well. And for brick, it was very similar. We had a project in 2010, and that was, again, reverse engineered from the Strata mix. So we also had confidence that this would also perform. And for our high wrap project, we made sure that we had two control sections. We had a high wrap section, and then we also had a conventional section so we can further measure actual field performance. So here's our mix design approach, balanced mix design approach. I was having some tough time trying to zoom in, but hopefully you guys can see it a little bit. At least the colors is really all you really need to see so you can kind of understand it. So this top part here, the contractor submits a JMF to the DOT. And again, it goes through all the volumetric design, we do gradations, TSRs, things like that. And once they pass all volumetric properties, it comes out of this green part here. And then it now asks this question in this blue part. Did it pass the gradation of volumetric criteria? If no, then again, like a typical mix design, no, they go back to the drawing board and then have to submit everything again. If yes, now they go to performance testing and then submit plugs so we can actually test the performance now. And again, we ask again, did performance pass? If not, it goes all the way back to the drawing board. They have to, modify their mix, submit a new JMF to the DOT, go through volumetric mix design again, and then come back through to performance again. And if it passes, then you get a performance mix that passed. So we're still doing volumetric design, but we're checking it with performance. If performance fails, they're allowed to go back and modify and modify their mix design so they can not only meet volumetrics, gradation of volumetrics, but also performance. So some modifications we made to our mix design criteria for our performance mixes is there is no binder grade specified. So for all our performance mixes, we just say provide a binder that allows the mix to meet the performance criteria, pretty much. And so what we do is once they provide it, and at Mix Design, they'll provide something, but we're more concerned on when it's time for the test strip. When they provide a certain binder at the test strip, we compare a binder later on during production to that binder that was at the test strip. And we want to make sure that it stays relatively consistent. Another addition is none of our specialty mixes that we run performance on have wrap in them. Wrap, as you can see by that other slide that I showed previously, introducing wrap into the mixes really makes the mixes very brittle, and it does not last in the overlay tester. The next 2 points kind of go hand in hand. We have an increase in AC content in those mixes as well as VMA. And also, which again goes hand in hand, to a decrease in air voids. The design gyrations was probably also came because of just our changes in super potency and dryer mixes. So those last two kind of go hand in hand. So during production, we test all these mixes, but we first start testing it at the mix design, then at the test strip, and then during production. So all those phases, you need to pass performance to be able to, meet our QA standards. For Hepto and that mix, we're doing a lot of. We test it every 3,500 tons. That is what we're calling a performance spot. And that is probably over the course of maybe 2 to 3 days, we're getting a full performance slot, which consists of 11 gyratory samples, which is 6 APA samples and 5 overlay samples typically. Brick, we're doing every 7,000. BWC is one per project, only because we don't have a big tonnage usually with these projects. So typically it's just one sample, and that's pretty much it after the test strip, and that's pretty much it. High wrap is every 3,500 tons, and BRBC is every 3,500 tons. So some impediments for QA testing that I see is that right now, for us to run a full performance on Hepto, let's say, it takes us 2 to 3 days if we have no queue of samples. And we're also, not only do we have a standalone overlay tester, because that's the test that's taking a long time, we also are running overlay tester on our AMPT. APAs are done pretty much in a day. That's a pretty quick test, but the overlays, you have to cut them, bulk them, make sure you're still you got the proper air voids. You have to glue them down and then condition them. So, it's a process. So it takes some time. So that's an issue I see with us going to full performance on other mixes, because we just don't have the time. Also, and wouldn't be able to get the results back in a timely manner. Also, space becomes a very big issue. And just to put it into perspective, I'm sure some other DOTs probably are feeling this as well. We are at capacity with our testing facility. And we're told we can't get another facility. So right now we're currently testing somewhere around 4,500 density cores in the season. And with the way our performance specs are set up now, we have another 5,000 performance gyros in the lab as well too. So just physically keeping these samples somewhere would be a hassle. Personnel is another issue. We have issues with retaining lower level titles because once they get some experience, an opportunity comes up somewhere else, whether it's NDT or not, they tend to leave. So and the hiring process at DOT is also pretty difficult. It takes us months to get somebody actually hired. You know, so when we lose people, it takes a very long time to backfill. And also, and I'd probably say maybe one of the more important ones is our current operating procedures. Again, as I said, we're at capacity. So if we are going to go for performance, which is the route we want to take, we really do have to take a look at our current testing program and see where can we make cuts, where can we make adjustments? Do we have the field test a lot of these performance? You know, it's a lot of questions that we have to ask on just our internal process. So to really go to full QA testing on all our mixes. And with that, that's the end of my presentation. Obviously, I'm not there to answer questions in person, but if I'm sent the questions later on, I can definitely send back my response. So thank you.
All right. And again, thanks to Stevenson for being able to record for us on such short notice and after 8 inches of rain in a property. I can't imagine how fun that is right now. So our last presentation before we get into question and answer will now be the contractor experience for New Jersey. And we have Kai Paulman from Tilcon, New York and New Jersey, a CRH company, joining us virtually. Has 15 years of experience, 6 years of those being at Tilcon. So hopefully have them up.
Okay. Thank you very much. All right, we have visual here. Testing 1, 2. Very much. All right. Good afternoon, everybody. Like I said, my name is Kai Qualden. I'm with Tilcon, New York. I'm the quality control director here, and I'll be following up on Stevenson's presentation to give you the contractor perspective from New Jersey. Real quick, I'll make a few acknowledgements. Cindy LaFleur, Rich Linton, as well as Stevenson with the New Jersey DOT helped given a lot of the background for some of the work that we've done over the years. So thank you for that, as well as all of our QC personnel here at Tilcon who inputted their experience and their perspective on what we've been through. So that's been a huge help. And another point of note, I should say, just before we get started, I am we are rather one contractor of many here in the state of New Jersey. So this is a perspective of our own, and hopefully you'll be able to get something useful out of this presentation. But certainly there are other experiences as well that are out there, and getting everyone's perspective on this is certainly crucial for having a successful balanced mix design project. That being said, we'll jump right into it. As Stevenson mentioned earlier, a lot of our mix design, our balanced mix designs are below. We have the high performance thin overlay, the binder rich intermediate and base course, high wrap, as well as the bridge deck mixes. So those will utilize performance testing, including the APA AASHTO T340, as well as the overlay, which files in New Jersey DOT B10. Also, the bending beam was mentioned. A lot of our experiences here at Tilcon involve the APA and the overlay, so that's why I focused on that. But certainly there are others as well. So even with the rubbing and the cracking, there are various criteria that each mix has associated with them, but they do all follow these two tests. What balanced mix design brings to New Jersey, at least from the contractor perspective, is I believe it's the opportunity for better performing roads. I think we can all agree that that is a high priority for everybody to put out a good product, to have a longer lasting road out there. So this, I think, brings us to the right place. The balanced mix design also offers the flexibility to optimize production, right? Focusing on the end product with our retting and our cracking allows us as a producer to focus on how we can improve our processes to optimize our mix. With that, I think that brings a more competitive market, encourages a competitive market, and potentially can reduce costs as well to the agency and the buyer. There's also volumetric flexibility. Again, focusing on the end product, there's the opportunity there to be more flexible and think differently about some of the volumetric criteria that we've had in the past, and encourage more of that out-of-the-box thinking. Some of the obstacles that we've had with balanced mix design and working through this, time is certainly one of them. To complete the performance tests, that can lead to delays. There's physically making the samples for the performance testing, as well as having them tested. Now, those just take time. That's a reality. So incorporating that into your project needs to be a consideration. It's also not an ideal situation to have a potential failure when you're halfway through a project that started at the beginning of the project. So that needs to be part of the process, is working that in. With high wrap mixes, that may slow down production. So that's a consideration. There could be an increased cost associated with the personnel and the testing. Us at TOCON, we send our samples out for testing. So whether or not it's part of the design process or during production, there would be a cost associated with that, certainly, as well as potential personnel needed in order to accommodate the added testing. If there's specialized oils involved, there's storage capacities that need to be considered. Where if you're using a different grade of binder than you normally use, or a specialized binder, you need to know where you're going to put that and coordinate that with your production. There's also the training and knowledge of the personnel and the people working on these projects, so that needs to be developed. And communication, of course, with the agencies regarding your specifications. You may have different agencies in your area working that want different criteria or even different testing altogether. So that all needs to be worked on beforehand, prepared before your project. As far as the design criteria goes, I would suggest certainly exercise good communication between the industry and the agency. I think you'll find a lot of what I'm talking about right now has already been addressed, or it's been brought up before. You'll notice with a lot of the other presenters. This isn't anything new, but a lot of the folks that have done this before have had good communication with each other, a good partnership with the industry and with the agency. So that's key. You want to do some research to establish your baseline data. And what I mean by that is know your mixes before you get into a project. You want to know where you stand with a lot of these performance testing. And you also want to have realistic expectations of what your criteria is going into a project. Certainly, we've been paving roads for a long time, and we want to make sure that our new specification is we're not reinventing the wheel there in some respects. And exercise transparency with results. Share the results between the agency and the producer. That's only going to strengthen our knowledge that we have on our mixes and lead to better performing pavements. As far as the quality control operations go, as I mentioned before, additional samples need to be made, whether or not you're doing it in the design process or you're doing it during production. If it's during production, whatever the sample and testing frequency is, you may need increased personnel in order to physically test those samples. So that needs to be considered. That was a big change, I think, in our operation, what we dealt with. As well as before, communication with the agency, and determining how things are going on the project. Changes to the mix design. A lot of the big changes that we've noticed were the higher binder content, especially several high rack mixes. And of course, just sound like a broken record, but it is the additional testing, our time constraints that, so that does affect our mix design and the process. as well as the different binder types. So different binder types is also a big change in the mix. As Stevenson said, on a lot of these performance or the balanced mix design, there's not a binder requirement. And so that's up to the producer set to figure out what binder works in order to achieve those performance characteristics. When it comes to improving results, our experience has been fast and accurate testing is only going to serve them better. And I think we know that in any case during production. The sooner you have results, the easier it is and better served you are to make changes and adjust if there are any problems or if there are any corrections that need to be made. As I said before, you don't want to have to find out you need to make a large change on a material halfway through a project and your results are coming in from your first day of production, a lot of material on the ground. And I think that's been said before from other folks earlier today. Increasing binder content can increase your performance characteristics. As you'll see on the chart here, I think there's a good illustration between your rep depth and your cracking life. As you increase or decrease binder, it will affect your wetting and your cracking. So there is, of course, a balance there that needs to be achieved. As you increase your binder content, you're going to increase your rep depth and inversely with cracking. So those are ways that you can adjust your mix in order to improve the results. Binder is also key. It is a big driver in not only the percentage of it, but the type of binder is a big driver of your performance. So determining the right binder for the right performance criteria needs to be determined. Avoid asphalt storage tank contamination. That's very important. You don't want to have commingling of materials in your tanks. It is a consideration or a coordination that needs to be made with the production facility because you can't. It will affect your results if a lower grade binder gets mixed in. The storage time of the material, if it's going to be sitting for a long time, that will affect your results, especially if you're getting small quantities of customer, or if you're coming in for a small quantity of the material and it requires a different grade of binder. The material needs to be mixed well, and so if it's sitting in the tank for long periods of time, it tends to separate. Also, rejuvenators, I think has been mentioned before, can be a good tool for improving performance results. But determining the dosage is also critical on that. The impact on field densities, certainly it can improve compaction. As we said before, a lot of these mixes, the binder content has been increased to achieve the performance characteristics. So your conventional mix fundamentals apply there. If you're increasing the binder and where the error weights are reduced, certainly you're going to have an easier time getting compaction or achieving compaction on the job. And which is not a bad thing, right? If you have lower voids in the plant, or if that is not a bad thing if you're ultimately, if your cracking and your wetting criteria are met, and you're achieving that performance, and you're getting density either faster or just greater densities period, that's only going to make our pavement better. So that's, I think, a win-win. And so, as I said, expanding the volumetric criteria, I think, is kind of a part of us moving towards the balanced mix design and looking at the performance of the mix. So looking back, after it's all said and done, what could we have done differently? Our lessons learned over the years, I think, would be plan ahead. It goes a long way, some good planning. If you know what your project is requiring, you can plan for that and you can get your ducks in a row beforehand. It's not the type of thing you want to learn on the job, in my opinion. Split sampling would be a great idea if you're working on a project. Accuracy of testing, of course, is very important, but also if there is a failure, it's great to be able to have that split sample to go back and verify your results. communication and sharing your information with your agency and vice versa. Getting that communication line to go both ways so that you have a better understanding of your mixes is also very important. And I would say more research and participation with agency and association. Going into a lot of these, really understanding the mixes and doing the research ahead of time so that, and working with your agency and your association to get that information out there is always good. So in closing, I think the ideal direction for a producer is to focus on that out of the box thinking. As we move towards the performance end of things and we look at our end product, really opening the door to think outside the box and to try new things. And if we're focusing on what our end results are, writing and our cracking, that's what we want to fix. What can we do to achieve that? It can improve our communication. It's always out there. It can always be worked on. So certainly that we want to work on as an industry altogether. We want to know where we're going. As we establish new criteria, new specifications, it's really important, I think, for us as a producer to know where we're going and the direction that we want to go. So, as well as technologies and materials progress, we expand our criteria as well. I think that's absolutely crucial that we keep an open mind as we head into this new era of production or of material, that we not only kind of expand our thinking on what we're doing, but rethink what we've done in the past. It's not to say that that's bad by any means. It's kept us afloat for a long time. But what I would suggest is, not necessarily have your standard conventional mixes and tack on a performance aspect, but rather really focus on a balanced mix design approach, where there is a little bit of give and take on both ends. So with that, I want to thank everyone for their time. And if you have any questions, we'll look forward to answering those in the panel.
All right. Thank you very much, Kai, for joining us. Unfortunately, there's technical difficulties. We couldn't see your presentation, but we'll get a copy of it and share it with everyone so they can also see the slides. With that, that's our last formal presentation, but we're going to kick off the question and answer session now. So I'd like to ask the 4 presenters to come up onto the stage. If you could join me up here. For what we'll do for questions, we have those in the chat online that can enter them, and we have people with laptops here that will ask them. But if you are here in person, you just come to one of the microphones, identify yourself, name and affiliation, much like for those of you that were at AAPT. Ask your question who you're directing it to, and we'll proceed that way. So you guys can come on up and we'll get started. So any questions?
Brett Stanton with the Asphalt Pavement Association of Michigan. My question's for the contractors. Storage silo time was mentioned in a couple of the presentations. So I'm just wondering if any of the contractors either monitored storage silo time during this or put any parameters in place to make sure that that was limited. And a follow-up question to that, if any of that was tracked, did you guys notice any differences, or how sensitive were the performance test results to differences in storage silo time?
I'll take a step first. Thanks, Brenton, for the question. I think just simple answer is no, because it's been a challenge, really, to check the silo time. Although, as you said, excuse me, it might have a significant factor on the performance test result, but typically during the busy season, it won't be too long for the material staying in the silo. So the silo time is really minimized. However, it varies from plant to plant and depending on the time of the year as well. But that's a great comment that we will be definitely, definitely worth looking further at and to see if we want to set a limit, say, try to minimize the time to minimize the impact, how to say. Yep. So that was my answer. Thanks.
Thank you.
We do store quite often. Perimeters, we try not to store more than one night. It's rare that we go longer than storing over more than one night if it's a rain event, but it's very rare. We did not track it that closely to see how stored material, the results versus the results made the same day. So it gives me something to look at in the future, though.
All right, thanks.
Jean-Paul Faure with Scholars. So this question is for Chen, and it's not really a question, it's comment on our discussion during the break. That's the one of them, and I have two remarks after. So our discussion point was about the difference between the limestone and the granite on that I-fit that caught my attention. And so the comment was to look at the loading curve and where it's coming from, whether the fracture energy of the slope, that will probably help understand why this difference, dig a little bit in the cause of this surprising difference. And also after that, looking at the binders, stripping compatibility, whether with granite or limestone. So I don't know if you want to elaborate on that.
Sure. The first comment about the I-fit numbers, I agree. I think what we just communicated during the break about the importance of looking at the curve rather than the parameter itself, because it may be caused by the fracture energy, which is the area on the curve, or by more of the related to the stiffness, which is represented by the post-peak slope. So as John Paul mentioned, that there could be two significantly material behaviors by having the same FI number. And honestly, we haven't looked at that, but it's definitely worth looking further into this, and I'll dig into the data and share with you later as well.
And the second point that we didn't discuss, but the break that caught my attention also with the fact that your production mix comes out softer than your design. And to go on what the gentleman from Michigan said there, we had those issues also in some of our earlier production of high variability of I-fit, depending in particular on the point of sampling. Because if you take the truck, so you just read, but if you take behind the paver, most of the time you have to cool down and read totally. And that has affected a lot our I-fit numbers, to the point that for that particular DOT in Illinois, we decided to go to from the truck, period. No reheating from behind the paver. So I don't know if you can elaborate maybe also on the reason why your production mix would be softer than your lab compacted specimen.
I'd say I suspect it is mostly related to the aging. I think Stacy actually mentioned in your presentation that they actually use 2 hours for the rotting test, right? And the Cantabro as well, but use 4 hours for the cracking test. And also NCHRP 9-52 recommended, using shorter aging time to represent the, short-term aging through the production and also late on as well. So might be more related to aging, but I'm not sure until I got further data to look at. Yeah.
Yeah, we're gonna switch, do online question and do kind of do 2 for 1 with the in-person question. So go ahead, Fan.
We do have one question from Chris Edwards that came in during one of the Vermont presentations. His question reads, has a correlation been established between lab specimen and field specimen for the testing results? What should we expect during production in relationship to the lab results? Any panel want to take that question?
Could you speak up again, please? Because we couldn't hear that very clearly.
Oh, okay. All right, I'll repeat the question. Has any correlation been established between the lab specimen and the field specimen for the testing results?
I'll try to interpret what I think he was asking is lab mix or mixed design samples versus plant mix. And I think Ching presented some results comparing lab mixes to plant mixes from the same mix design. And you showed that a lot of cases they were softer, which indicated that the rutting numbers went up and the cracking numbers, the cracking resistance improved. I think that's what Chris was asking. If anybody would like to elaborate on that observation about lab to field differences.
Yeah, as I mentioned earlier, as far as Cantabro is concerned, design versus production, not much of a difference. And for the short-term aging, for the 4 hours, design versus production, we've definitely got better numbers through the plant. But the short-term aging was close. I mean, it wasn't far off. Now the 12-hour aging was way different, but that's about all I have on that.
All right. Trey, you got anything else to add on top of that?
Sure, I just don't want to really talk too much, you know. I think as shown in one of my slides, they're listing the potential or talking about the potential factors during the production which can affect the performance test result between the design and production. That actually can be tied up to a lot of factors. Such as the production variation and also the binder source and aggregate property changes as well, a lot of factors. Although the goal is always to match the production numbers with the design number, but it's really a challenge for getting to that point. So the thing that we can do is just keep collecting the data and see if there's a major trend. If not for 100% of the mix, if we can see the trend through like 60, 70% of the mix, maybe we can get to know, you know, what's really controlling that and cause a difference between that. So,
all right, thanks, Chen and Danny for the comments. The next question, assume this is, you know, for the DOT panel members, is from Blair. What qualifications, training, and the certification program do states require for personnel that run the rutting and the cracking test for balance mix design?
So far for rutting and cracking, we don't have a requirement. The idea is that we're going to incorporate it into our mixed design courses and some of it would be the plant and field courses, mostly the plant courses, so that you can get, you know, the things with proficiency. The problem is, you know, until we get some precision and bias statements, it's hard to enforce how good you are at repeating the test. But yeah, I think that's coming. You know, it's just a matter of time.
Okay, thanks. Eric, do you have anything to add?
I will agree with what Stacy just said regarding precision and bias statements overall. Currently, we don't have any requirements right now in terms of proficiency for rutting and cracking tests, but I envision at some point our regional certification program, NCHRP, will take this into account. And last I checked, they have been revamping the courses over the last few years. And anyone in this room can correct me if I'm wrong on that statement, but I'm not directly involved in NCHRP in general, but that's my understanding.
I just start by thanking everyone for their presentations and sharing your experience. Brett Williams with the National Asphalt Pavement Association. My first question, I think, Stacy, you mentioned designing asphalt mixes through the plant. And I know a lot of agencies have like multiple point mixed design. So I was just curious if you could maybe share a little bit about like how, if there's variances in the mixed design requirements or what the requirements are, or how that's done through the plant versus through the lab.
Honestly, I can't say a whole lot about how it's done. It's just from some conversations with folks that say that they're, rather than doing a full lab design, they're running their designs through the plant so that even during design, I think they're able to submit information that's going to be accurate and matching what they're going to get later. But yeah, we do have requirements on, gradation bands, asphalt content, air voids, the whole 9 yards for design. But yeah, I was trying not to pry too much. But it was just some side effects of some conversations.
Okay, thank you. I have one other question that I'd ask, and this one was for Aaron. You mentioned an upcoming or a requirement on Delta TC requirements, I believe, in your presentation. And I was just curious because you had mentioned that you have polymer requirements, and I just didn't know if, because there was a presentation even this week at AAPT about how polymers can have a negative impact on Delta TC. I just didn't know if you have some thoughts or could share like what you're doing as far as that goes.
Sure. So right now we only require SBS polymers in our specifications, and as part of rolling out the Massacre PG binder grading system in Vermont, we are going to open up the possibilities regarding what modifiers will be allowed on both the high end and the low end. And basically for Delta TC, I don't have any thoughts specifically regarding SBS polymers in Delta TC, but what I can say is that we are going to have a -5 degrees Celsius with 40-hour aging involved. Does that answer your question?
I think so.
Okay.
Swati with Asphalt Testing Services and Engineering. Great presentations, everyone. I think my question is more towards the DOTs. So how likely are you to consider long-term binder performance when you're developing this whole framework for balanced mix design? And I also want to hear what the contractors think about that in terms of figuring out their binder supply when getting your balanced mix design together.
Having a hard time.
We're having a hard time hearing. There's a lot of echo.
Yeah. Long-term binder performance.
Yes, how likely are you to consider long-term binder performance when you are getting the balanced mix design specs together?
Specifically looking at long-term binder performance, I don't see us doing that directly, but during the design process, currently we're requiring an overnight aging or long-term aging for test specimens. And we would expect that in the cracking test to indicate some of those aging properties. Not as far as I'm aware, none of our producers are set up to do the binder testing. I mean, we operate on COAs and BOLs from the terminals. So I wouldn't expect that unless we decide to change our approval process for binders coming in to reflect that. And I don't think that's on the table at this point.
Okay. I mean, as Chung, he had in his presentation, binder definitely showed a difference in the IFIT values. So that my question was just tailing off of that. Thank you.
I'll also add that we're not necessarily looking at long-term binder performance either. We're starting to move towards testing the cake, if you will. So long-term aging overall of the asphalt mixture itself is more of a concern for us as an agency.
All right, we do have a few more questions from the online audience. The question asks, how do you adjust to get a balanced performing mix if you have constraints on like no wrap use or limited virgin aggregate availability from the contractor or the mix design perspective?
have to repeat that again. I'm sorry.
Okay. I think I'll rephrase the question a little bit. So I think this is a question asking from a, producer perspective. If the agency have a limitation on the wrap content or the recycled material content, and then given the location of where they are, they have very limited like virgin aggregate choices. So what can they do to adjust their mix to get a balanced rutting resistance and cracking resistance? Does that make sense?
Well, I could take that one, or at least start it off.
Okay.
Okay, good. I think it would be very difficult. It would be difficult, or it's certainly more challenging. There are a lot of constraints, binder content and gradation and wrap content and whatnot. The binder content, the percent binder in the mix, as I said before, can help achieve either a rutting or a cracking criteria. So if you're having an issue with a high rut numbers, you reduce the binder content, that will make it, I'll give you lower rutting numbers, and the inverse for cracking. But there's also rejuvenators that are available that will help performance, as well as the type of binder that can help with the performance. But certainly, if there's a lot of criteria, if there's a lot of different restraints on the mix overall, that's going to limit your options as far as what you'll be able to do in order to meet that.
I think during the presentations by the three contractors representatives, I think we all touch upon this here and there, and there are always challenges and constraints as regards to the mixed design adjustment. And one of the things that at least we learned from this pilot study is if you have the option on the liquid supply market that you can choose from, maybe try different liquid sources and see how it goes. It may not really fit for a specific location, but maybe work for another location. So maybe that's one of the ways that you can look at, one of the easiest way, I'd say. But if you don't have that option, and you have other, constraints like the aggregate source, you don't want to adjust the AC content and many others, perhaps you have to reconsider the way that you design the mix, the aggregate structure as a whole. So just try, if you are using the fine gradation, just try the coarse one and see how it goes. Although it could be a challenge during the laydown and the compaction, but there will be a different story, but at least just try something and see if it can work out for you. So just try to do your work and see what works best for you in your situation. Thanks.
Yeah, as we spoke on, I think, there's a lot of variant factors that influence ideal values. Having a great relationship with your aggregate supplier and running tests during season on your aggregates is very, very crucial. It's amazing just the aggregate change in GSBs and particle shape that take place during the season. And staying on top of that, all those things are going to affect the outcome of your ideals, especially, here I'm talking about high wrap, and, that's a challenge, but it can't be done. You got to know where your wrap's coming from. You got to know what's in it. You got to have some space to isolate different types of wrap. You got to run tests before you put it in your mix. It's very, very involved. You got to be proactive rather than waiting for a change to happen and go chase after it.
Next question is regarding benchmarking. As a few of the panel member discussed the importance of doing the benchmarking. So this question is asking, what exactly does benchmarking the mix means? Since this is probably someone that does not have too much experience about balanced mix design, so just want to get some, get started with what benchmarking means.
What we consider benchmarking is taking whatever mixes we're producing right now and testing them as if they're a BMD and find out where we fall. You can't move your mixes forward, whether you're industry or on the VDOT side, to write the specs until you know where you stand now, so that you know what needs to be improved and what direction you need to go. So that's what we've been doing.
I'll second that. You need to know where you are before you can go anywhere. So understanding your mixes and just where, if you took your everyday mix, where does that leave you on a performance scale? That's your starting point. That's your benchmark.
I'll just add to that definition that Stacy gave. I think that's quite consistent with what I think most people consider benchmarking is understanding what your current mixes are in terms of the performance test, whatever test that you're going to use. I'll add to that one thing is that you probably want to do benchmarking on both lab prepared mix, as well as plant produced mix, because there can be differences, as we've already kind of discussed a little bit. So 2 parts, I think, to doing benchmarking: lab mix, lab prepared mixes, and plant produced mixes.
So the next question is specifically asking the New Jersey presentations. How long do you allow for mix design verification process, or is there a time limit? I think this is something that Stevenson brought up, but I know he's not here with us. I don't know if that's something, Kai, you will be able to provide some response.
That's a good question. I can look into that and email that the questionnaire for that.
Okay.
For the exact time period that it takes. My understanding of the question is what is the turnaround time for testing?
No, how long do you allow for mix design verification process?
Okay. Yeah, I'll defer to Stevenson on that one.
Okay. Well, if you have the answers, send us a chat. Send us the comments in the chat box, and we'll announce to the group. All right. The next question is very interesting. I mean, that's a question many of us have, including myself. Which performance test is strongly correlated with field performance?
We wish we knew.
Yeah.
It depends on where you are in the country. Let's put it that way.
Randy, you want to talk a little bit about what we found out from the cracking group in terms of the lab versus field correlation?
Yeah, I'm sorry. I was reading some of the other questions online, so I'm probably, the question was about lab to field performance.
What is a basic cracking test?
Oh, well, that has been, the holy grail question for 5 years, or as long as we've been looking at different tests. I think NAPA actually put together recently a nice little publication that says, these are important things to think about in selecting what test you want to use for your BMD. And the number one thing is correlation to field performance. That's actually the hardest thing to figure out. And that's one of the reasons that we got into what we call the cracking group experiment back in 2015. I'll come back to that in just a second. But first of all, there are other important considerations that the speakers already brought up this afternoon that are also very important from the implementation point of view, or implementability point of view. Turnaround time, variability, ability to sensitivity to the mix effects that we know have an impact on performance. All those kind of things are important factors in making that decision. So going back to the lab to field correlation, we wish we had a lot of field performance data for all of the mixes that we've started testing, but it takes a long time to kind of build that information. So we put together an experiment in 2015 to build test sections and evaluate test sections at the NCAT test track. We just completed that work earlier this year, where we looked at field performance over a 6-year period. And we had in that experiment mixes ranging from good cracking resistance to fairly poor cracking resistance. And we ran a number of different tests most of the BMD tests that have been talked about today and earlier this week at the AAPT meeting. So we looked at, I think, six or seven different cracking tests. Most of them had a pretty good R-squared or correlation between lab results and field performance. The best relationships were on mixes that were aged. Aging is a very important factor in cracking resistance. Okay, so we included that as part of the study that we did. So rather than trying to spend 20 minutes talking about that experiment, what I'd like to do is just reference that report that's in the resources. Again, that's that QR code that's on the program or the agenda. Look for that NCAT cracking group report. And basically it lays out for you all those correlations. So again, the long and short of the story is most of those tests have pretty good correlations to field performance. So that checks the number one box, you know, in our decision-making tools. So you can go to those other things like simplicity, cost, repeatability, and let those kind of be the factors, the other factors that really drive that decision.
Richard Willis with the National Asphalt Pavement Association. This will probably be more directed to Aaron and Stacy. Most of the states that we're talking to about BMD are very much in that, if you look at the 4 different types of BMD or categories, they're very much in the phase A, where they're looking at controlling volumetrics and controlling performance, which takes a target that was that big and now makes it that big for contractors. And we're more interested probably in that type D BMD because it allows us to look at what's available in the different part and what is around us and try to make the best mix using locally available sources or sources that maybe are under a vertically integrated company's control. How can industry work with states to move them out of that type A BMD kind of down the scale to where there's a little bit more opportunity to innovate and use some different types of materials that maybe we didn't always use in the past to try to really harness the potential from these different materials. And Stacy is a state that's looking at A and kind of D as well. It might be, I'd be interested to hear why y'all kind of went with that approach, or what made you comfortable with saying, you know what, maybe we will dabble a little bit in this other area.
Well, I mean, the reality is if you stick with that A mix, you are taking that target and just shrinking it. If we want to look for, you know, from a state perspective, we've got to look at economics and competition. We're a low bid state. If we, the more we shrink that target, the more expensive our mixes get. If we can say, well, this part of the target can go free, we're going to aim over here, but everything else you can do your way. We've got more opportunities for innovation. We've got more opportunities for competition, you know, better economics coming out of it. You know, it's a mutually beneficial thing. In getting there though, yeah, I mean, I think there's that natural tension between, I guess you would call it, the DOT and the industry of, can you trust each other? For some, but you know, I mean, you know, the idea is that the DOT is here for the public good, but the industry is here to make money. I mean, that's the way we are. And so getting over that to really realize that all of this is in both best interests. You know, if we keep doing things the same way we've been doing them, we're going to get the same results we've been getting. And maybe this makes me optimist, but I think it's in all of our best interests to look outside the box and open our eyes and be willing to at least try things. You know, maybe we try something, it doesn't work, so we back off some. But quite frankly, I feel like from a DOT point, and this is me in research speaking, I can't say for the DOT point, I don't see that industry doesn't want this to succeed. So I feel when we've gone into these projects, Danny and I've talked a lot. We both want this to work. So we're both going to bring the A game and try to make it the best we can. If a company wants to stay in business and do better, they're going to need to bring their A game. And it needs to become an expectation and just a way we do business. Unfortunately, that still falls under that low bid system, but we're hoping that we can find other ways to incentivize that A game. But I think it boils down to, in a lot of ways, just getting experience doing this. I mean, if we said we were going to completely throw out the box on anything, whether it's mixed design or, looking at concrete, looking at steel, everybody would freak out. We take it in baby steps. So we've been doing limited trials. The more limited trials go well, the more tonnage we put out, people become convinced that yes, we can do it successfully, and we can get a better product out of it. And it's just kind of that shift in mindset. And it has helped, in our agency and in our industry, we have really good relationships. I think probably the best they've been in 20 years between the agency and the industry. And so, we're all moving kind of in that same direction of collaboration and cooperation.
I unfortunately cannot come up with a better answer than what Stacy just said. But from my perspective, I think the relationship between the paving producers and contractors and the state DOTs is getting better and better each year.
In follow-up to Richard's question, a lot of states do things like, have done things to get more binder in their mixes, like regress air voids and change VMA specs and that type of thing. And when you do that, you're messing with volumetrics, right? You're shifting away from what's in the it's historically been used. So you're sort of forced to do that anyways. So I want to, I guess, reiterate Richard's question. In messing with some of this stuff, some work that we've done is been designing mixes at lower air void levels. You've got higher effective asphalt content when you actually look at the effective binder content, and you're not getting any issues with your wheel tracking test results, for example, but getting very good cracking test results. And if durability is what we're after, I think we should be given that, due consideration. And, I'm old, I'm an engineer. I don't want to give anything up either. I'm not going to tell you to look at volumetrics, but I think that really hanging on to volumetrics and not allowing designers to step away from them to get better performance is really sort of short-sighted on the industry. It's not everybody's part. So maybe you don't want to respond to that. It's just food for thought.
Going also to Richard's question, the one biggest part of this is that you have to have real faith in those tests. And that's, I'd say, where the real lack of faith is in the test. What happens, when I put something in it, and I'll give you the perfect example of that, because we've all had experiences with it. We thought we had a performance-based binder specification, right? These tests are going to tell us everything we wanted to know. And then we found out that, well, no, they really didn't. I could put a little of this and a little of that. The tests looked great, but things went bad. And so that's, I think, probably part of that learning curve. And that's why Stacy says, well, we do trials and we look at this and we look at that, because everything we do is really an estimation, a model. It's not the real world. And so if we try new things, well, is this modeling that we're doing, whether it's with a test or something else, really reflect performance in the real world under traffic? So you got to take those steps, but, and that's exactly what's happening today. And I think that, that's great with some of the trials you do. And as you get more faith in the test, you try more things in the test to see what you look at. And I think that, again, with, if you get NCAT with the track and some of the stuff they're doing, they expand on that knowledge. You got each state does something different. Now, I can't transfer maybe what happens in Vermont to Virginia, even though they both start with a V, I guess, but you can't, doesn't work that way. But at least that gives you something to say that when someone else tries something different, if it at least doesn't fail, it may not work for me, but it didn't fail for them, so it's something I can try. And I think that's going to be the key part, is to get that knowledge out to everybody.
And I'm gonna take the opportunity of standing up here to just share a couple perspectives that we heard from some of the case studies of other agencies out there as well on exactly your question, Richard, Adam, and John, is that a lot of agencies we talked to did want to start with kind of the approach A of narrowing that target, and then wanted to see what wasn't necessary anymore, maybe from their specification and take away there. We did get some thoughts from some of those agencies, though, that, volumetrics may still have a place in determining whatever the aim is, not a right voids content for every mixed design, but seeing that it was consistent. It's a tool to potentially use there, but considering that as well. And then the last perspective that came out from those case studies that I'd share, especially what you just mentioned, John, is that, again, implementation is going to have to be iterative. It's always going to have to be, so we don't fall into what you just mentioned about the PG binder spec of, continually checking back against performance with whatever tests you have to ensure that that relationship is still there. It may not be, okay, we have that relationship, it's done, we don't have to worry about this anymore, we're implemented. It's more likely to be something that's iterative that these agencies said they're going to have keep an eye on. So just something I want to share. Go ahead, Randy.
Yeah, I'm just going to, one of the questions that has come up, and maybe I'm repeating it, but I've heard this question, not just this afternoon, but before, is how is the criteria set for these performance tests? What is the lab to field correlation that helps us establish what the number, the criteria should be? And I'm not going to give you the answer because that's part of the discussion tomorrow for the breakout sessions, is for us to really debate that issue. Some of the ideas I think have been presented this afternoon. There are other ways to do that. And it really probably needs to be discussed more about how we should select criteria for our tests. And it takes time. That's an opinion, but that's not the answer. Okay. Derek, I'll turn it back over to you to offer a few closing comments, including the comment about the
cups. Yeah. So first of all, I want to thank our presenters and our panel for sharing their experience and everything. It's really helpful for everyone. So let's give them a round of applause. So just a couple reminders. Number one, the reception at 5:30 right outside here. So we'll see everyone for that. And then the other thing is we wanted to mention is double APT did wrap up at noon today, and there are extra coveted double APT coffee cups available on the table out there. So feel free to take one. Even if you didn't attend, go ahead and grab one while you're out there. And again, thank you everyone for this afternoon. We do start at 8 a.m. tomorrow morning with talking about benchmarking some more. So thank you everyone. And again, thanks to the panel, and we'll see you about a half an hour. All right.
All right. Good morning, everybody. It is really blinding to stand up here and try to look out at the crowd. It's like church. Nobody wants to sit in the front rows except for Barry. Thanks. All right. I hope everyone had a good night. For those that were in Nashville, it looked like it was a very nice evening to go out and have some fun on the town. For those that are joining us virtually, I hope you had a nice evening as well. I'd just like to thank Napa again for the reception last night. We enjoyed that very much. So we've got a few things to talk about this morning, and I'm going to jump right into it. My first presentation, I think we'll get that going here in just a second. All right, so what I want to start out with this morning is we've been working on this thing that we're referring to as the BMD implementation guide. really what this is part of some work that we're doing for another NCHRP project, NCHRP 10-107. The title for that project is Guide for Implementing Performance Specifications. And we're a sub to ARA. ARA is handling the concrete side of this guide. There's performance specifications being developed by them for concrete, and then NCAT is handling the asphalt side of it. So they're parallel efforts. And it started sometime last year. And we started drafting kind of the steps toward implementation. And we came up with 16 steps that are listed here. And then at some point last fall, we had a meeting with some of the folks from the University of Nevada, Reno and FHWA. Okay, didn't know this. We went to 8 steps. We consolidated 16 steps to 8 steps. So that seems like we're getting rid of a lot of things, but in actuality, we were just kind of sorting some of these steps out and kind of making them, some of them sub-steps within some of the major steps. And if you were here a few days ago for the AAPT, last day of the AAPT, actually it was yesterday morning, Dr. Ely Hodge kind of walked through these steps as well. And so now we're on the same page about what are the major tasks toward implementation. And that's what I'd like to spend some time talking with you guys this morning about what those steps are. So we've started drafting this, not just in a PowerPoint form, but in a document form. We currently have a draft of this guide that is being reviewed this fall. We're going to be meeting with several states to kind of go through this with them and let them criticize what we've written. We can adjust and kind of improve what we've written and then have the final product out sometime next spring. We'll also be doing workshops sometime this winter to actually kind of present this information in a longer format than what I'm doing in this 45 minutes or so. But the guide has 8 chapters corresponding to those 8 major tasks in the previous slide. But I'm going to go through those kind of one by one and just kind of hit some of the highlights of what those chapters, what those 8 tasks are. So the first one is motivations and benefits of balanced mix design. Starting out with what are performance specifications. Again, that's the title of the overall NCHRP project is a guide for performance specifications. So it's a good starting point. Have to talk about why we want to change. What are the motivations for change? Talk about the benefits of balanced mix design. Some of those have been talked about a little bit already the last couple of days. And all these steps, the steps in the process, some of the major steps and obviously some of the sub-steps. Chapter 2 is planning the process. And one of those is to identify champions in the organizations. This would be the highway agencies. You know, you're going to need really support from the upper levels of the DOT as well as from industry. The second one is establish stakeholder partnerships. And that was something that was highlighted yesterday by Virginia and Vermont and New Jersey. And I've heard this from other states, is it's really important to have this good working relationship. They call them task groups or partnerships or whatever, specifically on implementing balanced mix design. And that's really important because there's a lot of details that the industry and the agency need to be on the same page about. Part 2.3 is identifying all those issues and the resources. So there's a lot of information out there on balanced mix design, a lot of good information, and you need to sort of sort through that information and spend a little time kind of reviewing what others have done, some of the lessons learned, that kind of thing. Next part is establishing goals. What really do you want to implement? And how quickly do you want to implement? Do you want to implement just the mix design test and then think about quality assurance as a future thing? Or let's kind of do it all together. Those are kind of things of goals. Then you got to map the task out. Again, Stacy Diefendover yesterday presented a really nice kind of plan that they had in Virginia, or have for Virginia, of laying out kind of that timeline. I think that's really an important kind of for everybody to understand. You know, there are steps that you have to go through. And again, looking for external informations and support. You know, there are resources out there, FHWA and their cooperative agreement with UNR, NCAT. There's other research organizations that are there to help you as you go through the implementation. The last part is back to that Gantt chart, you know, really kind of identifying the steps and the task and how you plan to work through those different tasks. Step 3 or task 3 is selecting performance tests. And this is what we tend to focus on a lot of times, is really what are the tests that we need to use. And this is really a major decision point in the process. But before you pick your test, you really need to understand what are the types of distress that you have. You know, is it reflection cracking? Is it moisture damage? Is it fatigue cracking, rutting? You heard again from Virginia and other states. A common theme is that, you know, rutting is not a problem in most states around the country. So do we even need to do a rutting test? Well, we probably do, even if we don't have rutting now, because we're going to be modifying our mixes. We're going to be adjusting mixes to make them more resistant to cracking. We don't want that pendulum, if you will, to swing too much to the side where we end up with a rutting problem. So, but it is important to understand what types of distress you need to be working on. Thermal cracking, reflection cracking, top-down cracking, bottom-up cracking. To me, those are different modes of cracking, and the tests that you may select for those different types of distress may be very different. And then 3.3 is validating the performance test. So you're going to make probably a decision about your cracking test, your rutting test, moisture damage test, and that kind of thing. But you may want to go back and let's really validate that for our state, for the state that you live in. And I think a really good example for us on how to do validation work is what we did 25 years ago when we did some of the LTPP projects, like the SPS5 projects, looking at RAP. These were early SuperPave era kind of projects where we built test sections in a lot of different states on, you know, a route, you know, and all those 8 test sections were subject to the same environment, the same traffic. So the only variable within these test sections was the mixes. And I think that's sort of what we need to do with BMD as well. And that means you're going to be running tests on all these 8 test sections, and you're going to be watching performance over time. And that information would be very helpful as we want to modify the criteria that we set later on in this whole process. The next step is acquiring equipment, managing resources, talking about training and evaluation. So I think a couple of presenters yesterday talked about this. It's one thing to get a budget set aside for getting equipment, but there's a lot more to it than that. You know, sometimes you have to rearrange your laboratories, reallocate space, decide, you know, what you can do without maybe in your current setup and those kind of things. And then training needs to happen, not for everybody at this point in time, but at least the people that are going to be running tests in the early stages of implementation. You need to get training for those people. And there are different resources out there for training, whether you do some training using the equipment suppliers, or you go to, regional workshops or hands-on classes and things like that. There are a number of different places for getting training. Evaluating performance testing could include things, I've got down there, conducting interlaboratory studies. I think several people mentioned that yesterday. The real value of doing interlaboratory studies or round robins, it helps everybody understand how their results in their lab compare to everybody else testing the same materials. And most of you are probably familiar with doing proficiency samples and things like that through whether it's the APRL program or the formerly AASHTO Materials Reference Laboratory, or through your own state's proficiency program. Those are really good things to set up and start working toward to make sure we don't have a lot of disagreement between laboratories about what the numbers are. The next step is establishing baseline data, and this is a big task, a really big task. And it's really trying to gather the information needed to help set criteria. So for some of the tests that are going to be implemented, the state already has probably a good bit of information. They may have implemented, for example, Hamburg 10 years ago or 15 years ago. And they've got a good history of Hamburg results and those mixes how they have performed in the field over the last 10, 15 years. So that kind of information is very helpful by looking at what you have and what your pavement management system data says. It was mentioned yesterday about conducting benchmarking studies. Following me this morning, we're going to have two states come up and talk about their benchmarking studies to go a little more detail about that. That's a key part of this chapter. The next one is conducting shadow projects. And I'll explain what shadow projects are on the next slide, but some people have been referring to these as pilot projects or early projects. And we'll make some distinctions about what shadow projects are and what pilot projects are, at least the way that we've defined those. There's not a standard definition for that, but we're trying to help explain the differences between shadow projects and pilot projects in this guide. The last step in this chapter is determining how to adjust mixtures containing local materials. And this is not just researchers, going through studies and saying, all right, yeah, this is what happens if you go from an unmodified binder to a polymer modified binder. This is contractors, real mix designers, learning with their materials how to adjust their mixtures. Okay, so it's okay to learn and read what other organizations have done, but there's nothing like having the equipment and running the tests with your own materials. So that needs to be part of the process, needs to be part of that learning process going on right here. All right, so this is about benchmarking. Stacy gave a good definition yesterday. What I defined it here is a study to establish a database of test results for currently used mixtures. In two parts, lab-produced mixes, and you can use this example perhaps as a way to set mix design criteria, and plant-produced mixes maybe as a way to establish acceptance criteria. There's a lot more to that kind of decision process than what I'll go into right now. The analysis of benchmarking, I think you'll probably see some examples, so I won't go into the nitty-gritty at this point in time. But one of the key parts is looking at that distribution of CT index results or flexibility index results or SAP results or whatever the test that you choose. What is the range of results for the mixes within your state? And you may have to break it down as to mixes of different types, mixes in different mix categories within your state. Maybe your higher traffic mixes, your lower traffic mixes, those kind of things. All right, so this is what we're defining as a shadow project. And it's a project in which you're gathering mixes from those projects at a frequency that's similar to what you're currently running your current acceptance tests. Okay, so every sublot where you're gathering mixed samples, you need to be doing that within these shadow projects. So shadow projects has a number of goals. One of those being it's a way to get more people familiar with the tests and how to run those tests, how to prepare samples. This is going to add to the information in the benchmarking database. But the third goal right there probably is the most important, and it's not talked about too much, but it's to gather information on typical production variability. That production variability is different than the variability that we keep talking about, the coefficient of variation within laboratories or between laboratories, because this includes also the variability of the materials changing during production. You know, that variation in asphalt content, the variations in gradation that are going to impact. That needs to be understood when you're writing the specifications and writing and putting down limits for each of these tests. So once you have all that information, you're ready to start developing your specifications in your program. You may have to alter your current sampling and testing plans. You may redefine what you call a lot, sublot, those kind of things. You may not. This is where you're starting to really put together specifications, provisional specifications, I think is what Vermont called them yesterday, where you're going to use those on these real pilot projects. And using that information to really, I think, revise and adapt, keep evolving those provisional specifications. So a pilot project is different than a shadow project, at least the way that we're defining it. A pilot project is where those new criteria, those new specifications are actually being used and enforced. And contractors will have to know that as part of the bidding process. I got to know what the new limits are, and they'll include some uncertainty in meeting those targets in their bid prices, right? And the goals of pilot projects are, again, to expand the number of stakeholders, people familiar with the test, and how the test can be run in the field and those kind of things. You're going to use these pilot projects to evaluate the preliminary specifications or provisional specifications in a real world project setting. You know, are the testing frequencies reasonable? Can we turn the results around quickly? Are the proposed pay factors, if you have pay factors based on these new tests, are they appropriate? And then even things like the dispute resolution system that you have, you know, part of your quality assurance program. And then we're going to have to revamp our quality assurance and our training programs and our laboratory accreditation programs. You know, it's a lot of new things for people to get familiar with. So they got to get familiar with running the test, but also, you know, the new specifications. What are the limits and how are we going to deal with those limits? Are we going to continue to use our current measures of performance or, you know, PWL, absolute deviation, whatever your state happens to use right now, or are we going to have to modify that? And the last step is obviously implementation. And that's not necessarily where you stop, because some of these are going to be iterative processes. You're going to probably, after you get to task 8, chapter 8, you're going to learn, oh, there's a better test. We're going to start this whole thing over again. But there may be that kind of things where we need to keep in mind that things are going to continue to evolve. So that's real quick, kind of the summary of the BMD implementation guide. Again, we look forward to sharing that document after it's been vetted a little bit more through this fall, gone through the NCHRP process and get it out. But I'll be happy to answer any questions that anybody has at this point in time. Everybody needs some more coffee? Come on, wake up, people. Anything online? Nothing online. All right, I must have been very clear. That's rare, right? Okay. Well, then we'll proceed on ahead of schedule, which is always good to be ahead of schedule. And I'm going to introduce the next two speakers. First, we're going to have Casey Nash from Maine come up and talk to us about the benchmarking studies in Maine. Casey is the asphalt pavement engineer for the materials testing and exploration branch or whatever office of the Maine DOT. So Casey, are you ready to go? Okay. Y'all give welcome Casey as he comes on up.
Yep, the brightness up here is very often, that's pretty intense. All right, so thank you, Randy. I actually haven't even reviewed that implementation guide yet with the latest draft. So I'm looking forward to the reduced step 16 down to 8. Much more feasible, much more reasonable. And some of the things that you talked about there are talking about like the variability aspect as well. That's huge. One thing that we haven't really talked much about at this balanced mix design implementation conference is balancing the mix design. We've kind of talked about, does it meet a performance limit? But what about balancing it? Is that really balanced if it meets the minimum? I mean, it meets criteria, but is it really balanced? So that, in my mind, balanced mix design is the best world of both, right? So we're talking a lot about rutting and cracking. That aspect, does it just barely meet the minimum on one end or the other? Well, you could go that way. You could lean one way or the other based on your local distresses. But truly balanced is meet in the middle. And then you're able to, that inherent production variability with the gradation, the asphalt content, your materials, you have some room before you actually drop beneath one of those limits. So that was just one thing that you had mentioned about that. We haven't really talked much about balancing the design and getting away from just, does it meet the minimum, the verification piece. So I just wanted to just kind of mention that because I don't go into it in depth in this slide here, but it was something I just wanted to follow up Randy on. So yeah, I'm the asphalt pavement engineer for Maine DOT. We've been doing performance testing for several years now. I'm here just to give you an idea of our benchmarking effort in hopes that some of the information will be useful for other states and other contractors. So I'm going to cover our motivation, some of our background with the testing, the methodology that we're currently investigating and looking into for the benchmarking effort, some of our takeaways at this point that we've learned, and just some questions we still have and questions that everyone will always have. So the primary motivation is that Maine DOT has seen a reduction in pavement life. Our pavements aren't lasting as long as they used to, and they're not lasting as long as we're saying they're going to. There are very few 20-year pavement lives now. So when you look at some of this mechanistic design that's predicting out to 20-year life, that's wrong. We're not seeing it. Not with asphalt pavement, at least not in Maine. We're seeing early failures even when the mix design meets volumetric criteria. With some of the newer, higher wrap, rubber, plastic, additional modifiers, emulsifiers, there's all these additional pieces are really complicating the baseline volumetrics. Even just the most common one, just polymer. Adding polymer can completely change a design and its productivity, and how it lasts out in the field. But volumetrics don't show that. You don't really catch that with a volumetric analysis. So that's really another big motivation for performance testing, is because the original SHARP piece was, a lot of people have implemented volumetric design, but haven't really filled out the entire original intention of performance verification. And we want to be able to provide flexibility to contractors to innovate. We've had increasing prices significantly over the last few years. to the point where our upper management is hesitant to look into new innovations, implement new ideas, or look into other options. It's, if anything, it's almost pushing them to reconsider our specifications and maybe loosening them some to try to be able to decrease cost, which is wrong. It's just the wrong direction. So we need to make sure we work good with the climate with our contracting agency, our contractors, but as well as our own upper management within the agencies. I can't stress that enough. They need to be on board. We can't just because the contractors are having a difficulty meeting a specification, doesn't mean the specification is wrong, doesn't mean the criteria is wrong. We just need to work together to try to improve the ability and everyone talk about training, right? Training is huge. Where the workforce is lacking right now on everyone's side. So we want to be able to provide some flexibility, open up the specifications some. So this is just some of a background of Maine, how Maine does their mix design process. So our contractors actually are the ones that do the volumetric mix design. They submit the paperwork and the overall package to us, similar to Vermont. We go through and make sure that it meets the volumetric design criteria and meets our specifications. And then we then go and verify the aggregate consensus qualities. And then we actually, for full approval of a design, the contractor needs to submit a plant verification. So we actually verify their volumetric design through a plant produced sample to truly approve the design. This is just some of our information here, what our test criteria is. We primarily use a 6428 and a PG64E28. And we do all of our designs at 65 gyrations because we were seeing that basic contractors, the only difference we were seeing a lot of times between the 50 and 75 gyration design was tweaking the asphalt content. And so that's the wrong thing as far as performance goes. We implemented Hamburg wheel tracker back in 2016. And the primary issue there was rivaling and rutting. We've been investigating, as you see here, the additional tests over year after year. It's always one of the never ending question, what test is right? We've chose the initial test there, the Hamburg and the ideal CT, based on some of the accelerated load facilities and the correlation to the accelerated load facilities field performance. We don't have the history of cracking associated to a cracking test because it takes years and years. So our best option to be able to select a test is based on those accelerated load facilities. We actually intend on investigating using mist and moisture induced stress test along with ideal CT to be able to potentially be able to use the ideal RT as a surrogate to Hamburg during production, because it will allow quicker assessment of that susceptibility as long as it continues to show and rank mixes similarly to the Hamburg. So for our typical acceptance samples, we get two box sample, and then we also get 2 additional boxes from that same split for contractor dispute. If there's a dispute, if there's a disputable property. If that's not disputed after a couple of weeks, we then go through a list and we make sure we hit every single mix design that is produced in the state, every design and asphalt grade variable. And we make sure that we mark 2 of those boxes and set them aside for winter testing. So then when we have every single mix design from every contractor in the state, we have volumetric properties, and then we have 2 to 4 boxes, so anywhere between 20 to 40,000 grams of hot mix to be able to do performance testing, to be able to associate, and so that we're doing this as an agency to try to be able to provide the contractors that benchmark variable. So they have an idea of where they stand. At this point, for the Hamburg, we've ran approximately 1,300 tests, AMPT, about 2,000 tests, 100 different mixtures. The ideal CT, 3,200 tests. So you can see that just simply the ability, the ideal CT and the ideal RT, those are some of the latest ones we've been investigating. I mean, you can just see the numbers and how quickly you're able to assess a mixture. It's just more reasonable for an agency and more implementable. And we just started looking at the high temperature IDT as well, because if we have a little mix after we're done with a Hamburg, ideal CT and ideal RT, figured why not? Might as well start, just another test that we're interested in the potential value. So the overall methodology with balanced mix design, yeah, Randy, I plan on taking advantage of your extra time if you don't mind. The balanced mix design methodology, most people are fully aware of what it is. We're balancing, you pick a couple key criteria, something that's a concern in your state. So in most cases, we're balancing rutting and cracking. So as you increase or decrease the asphalt content, you're going to have a change in performance of that cracking. Increase the asphalt content, you're going to have more of a risk of rutting. Decrease it, you're going to have more of a risk of cracking. But what happens with that volumetric optimum, the volumetric design doesn't fall within that acceptable performance range? What do you do then? So do you go through and should we just shift the asphalt content and still keep the same volumetric criteria? That's not going to work. That's just, but it's obvious that we obviously need to shift the asphalt content to be able to gain the necessary performance. Should we ease or remove some of the volumetric design criteria? Yeah, in my mind. I think yes, this is an opportunity to be able to loosen up some of the specifications, be less prescriptive. Should we change the PG grade? We've been doing some lab work where just shifting the grade, you can have a significant improvement. So you can still maintain the same volumetric criteria and improve the grade and improve your performance. Should we use a different test? Just because it doesn't, the volumetric target doesn't fall within our performance range, is that performance range right? Or should we just reject the design? Should we say we're so confident in these performance tests that this volumetric design won't meet the performance criteria? It's rejected, go back to the drawing board. I don't think that's the right direction either. So for our benchmarking effort, we're primarily going with the balanced mix design approach A, which is using that volumetric target, that volumetric asphalt content, and then just verifying the performance. So we're using the contractor's design. We're not having them shift the asphalt content. We're not trying to do lab batches. We're doing this all on plant produced mix from the contractors. So we really can only do it at their produced asphalt content. Here's an example of just some of the data, how we're looking at it. And you've seen some of these performance space diagrams before. It's a nice way to be able to visualize the balancing of your properties. This isn't all of our data. This is just a slide of some of the data I looked at, we had worked with last year. But I just wanted to be able to give an idea of kind of what we're seeing. So in Maine, we've implemented the Hamburg, which is a rut test. We don't have a cracking test. So you can see the overall centralization of the data is pushing up to the upper left, a stiffer mix. So we're and all of the vast majority have lower than our 150 criteria CT index. So we're pushing all of our mixes to be stiffer, drier, and and everyone knows it's going to be more crack susceptible, especially in a freeze thaw cycle, and especially in the northeastern climate. That's not ideal. So as far as implementation of the balanced mix design effort, we're kind of focusing more on approach B because it's lower risk than C and D, but it gives us some options, a range of asphalt contents instead of just a singular verification at one asphalt content target. It allows you some idea how to be able to shift that target, how to be able to move that volumetric optimum. So we're going to use a volumetric design for the contractor, perform the lab testing at the asphalt content, plus and minus 0.5%. Check against our performance criteria, our preliminary criteria. Then we need to do the moisture damage test. Right now we're using the Hamburg for that, but if we try to move away from the Hamburg some, we still need to make sure that there is a moisture sensitivity to the design. That can be assessed just at the design level up front, but as you change asphalt, it's in different suppliers. I'm just not confident that you can just do it once and say it's done for the design. Check, and then again, check against that criteria. Yet unset, but if it meets everything at that point, then it's approved design. Right now, the primary test we're doing for rutting is the Hamburg wheel tracker and the ideal RT, or the rutting test index. You can see here for the cracking, the AMPT, the SAP value, and the ideal CT with the CT index. We intend to look into the mist to be able to assess the moisture sensitivity, but we don't have any criteria yet. All numbers here are preliminary, except for the Hamburg. That is implemented. Everything else, the ideal RT is just from literature, some of the recent work. SAP value is recommendation from North Carolina State University. The CT index of 150 is from the NETC 18-2 study that you can find online. It's a Northeastern work that they compared some of our ideal CT data to field performance and found that the criteria of 150 is actually what we would need. Now, I will give a caveat there that that's also not 4-hour aged mix. At this point, we're trying to focus more on the relationship between what's being produced out in the field and the lab, so we can have some transition and the opportunity potentially to be able to for QC and QA. So on top, the next level of our benchmarking that we're looking into is being able to provide contractors with the ability to improve their designs. So we've started investigating, doing some research work. We started with just one mixed design and intending on shifting the grade. Try to capture the effect of what's a different PG grade on these indices. The asphalt content, the 3 different points, so we can actually get some sort of relationship. And we started with just the Hamburg wheel tracker and the AMPT, the more in-depth tests. After looking at some of that preliminary data, we found that there were points that just didn't make sense. Data was broken, things it just didn't work out. But after that point, we did so much work, so much involved testing, we couldn't just replace it. The mix was gone. So that kind of made us think, like, all right, maybe we need to look at some more of these basic tests, if you will, to get that we feel have some value. So we then increased it to go with 4 PG grades: 6428, 64E28, which is a polymer modified, 64E28T. That's just kind of our local name, turnpike grade binder. Has a minimum polymer content of 2.5%. Some of our contractors we were finding were using this bumped up 64E28 to be able to meet Hamburg testing. And so once that was indicated, it's like, all right, let's try to capture that in the data and share that with the rest of the industry. And then 76E-34, I just asked one of our primary binder suppliers to give me the best binder that you can, what you think is your best. And they call it their bulletproof binder. So just like, I just want to know where it ranks. Is it worth it? Does the data show it? We did the Hamburg wheel tracker and AMPT as well again, but then we included the ideal CT and the ideal RT, quicker, more fundamental tests that just to be able to see, does it work? Do we capture the realistic implications here? Are we going to get the improvement in crack resistance when we increase the asphalt content? Are we going to get the improvement in rut resistance when we increase the PG grade, the high temperature PG grade? Here's an example of some of the data. I'm just going to go a little bit quick into our mixed design 2. This mixed design was a design that we believe was a good performer. It laid well, performed well. So we wanted to start with something that we knew was decent. The volumetric design looked and seemed to perform well. You can see here that the volumetric optimum, the contractor shows 5.7 based on their volumetric mixed design. When you do a linear fit to their submittal, it actually came out close to a 6. That's why the central point is at 6. But you see the volumetric optimum falls within the performance range. The acceptable range is that green area. And so in this case, the volumetric design meets the performance criteria. So makes sense. This one here is comparing the RT index and the CT index, those quicker, more fundamental tests. When we increase the binder grade, we see an increase in the performance window. So as far as the low end, it stayed consistent. As far as that lower limit, but you gain a lot on the upper end, on the higher asphalt content. And this was a good indication, though, that we're not really gaining the value in a higher modified binder without additional binder. You need to have enough of that binder to be able to really gain your value. So you need more of the more expensive binder to realize the gains. I'm going to actually use the whole slide here and share just to show some of the comparison of all 4 PG grades and the effect as you go from clockwise, lower left, up around. You see that performance window continue to increase. As you increase the grade, you're able to put it, you're able to get a much larger window. So some designs will be a very tight window. And that really limits you with that production variability, as far as you're at risk for failing your performance criteria. So with some of those designs, you may need to increase your grade. This is just CT and RT. This was one of them that the volumetric design fell within all the criteria. Performance method A, the BMD approach A would just be, yes, it meets. So you can just go with the 6428 and it's adequate. And that may be best, that may be fine. But in cases where you have increased risk of rutting or increased cracking concerns, you can use an increased you can use a higher grade binder, but you need more of it. This is just a quick shot to give you some financial aspect here, some association to the cost implications. So as you go, base 6428 at $600 a ton, and you see that increase in cost as you go counterclockwise, the cost increase can be significant, but are you seeing a performance gain? There's been recent discussion, some of the presentation that AAPT was talking about how the CT index doesn't really capture the polymer modification. The rutting does, it's shown in the rutting, but it doesn't really capture it with the CT index until you get into higher levels of modification. So you look at the lower left, the 6428 is about 200. You go to 64E, it's a little over 200. It's not an insignificant bump, but it's not that significant. But then you look in the top left corner with CT index of 337, that's significant. So some of the statements about it not capturing the polymer modification, there's validity to it, but once you get enough of that polymer, once you have enough of a network, you do see cracking improvement. Now, just real quick on the rutting, on those more complicated tests, the Hamburg wheel tracker and the AMPT cyclic fatigue. You see that with the 6428, it shows that the volumetric design was unbalanced. The design is too soft. We need to decrease the asphalt content. We need less of it for it to perform. That's not the case that we saw in the field. It was actually a good design, remember? So that didn't really make sense. The secondary point, graph there, we would have to replace that third point with the red data point. That's not reasonable. We know it's not right. As you increase the asphalt content, you're not going to have a significantly worse or significantly more crack susceptible mix. It's just, it's not realistic. It doesn't meet real world. So all that work that was done, all the replicates for that data point is gone. Now we have to go back and start it all over again. And again, to fill out the whole picture, there's the other two binder grades. So that 164E point, well, then once we went to the 64E 28T and the bulletproof binder, you see a significantly increased window. One thing we also learned here is that simply applying linear interpolation and extending it way outside of what you've actually tested is wrong. You look at those top two graphs there, it's saying that you can, you look at that red line, think about where that projects out to. It's saying that you can have a crack susceptible, a good crack resistant mix down to with no binder. It just keeps going. So you can't extend, we found that you have to work within your testing range. We can't interpolate. We can't really extend that data out past what the testing range. And again, the cost associated to it, you do see an increase in the crack resistance with the polymer modification of the SAT value. So that did capture the polymer modification better than the ideal CT, but it's a much more complicated test. And when something goes wrong, you have to go back and start over with a very complicated, long test. And now the Hamburg wheel tracker, this is just a quick glimpse of some of the work that we started looking into, is just comparing the ideal RT with the Hamburg wheel tracker rutting resistance index, the index value that includes the wheel passes and the rut depth. There is ranking the mixes the same. So if we can run a test in 30 seconds and we're finding it's ranking the mixes the same as a test that takes 6 hours up to, if I'm running the full 20,000 passes, I'm going with something that I can run in 30 seconds, especially when I can run 4 replicates and have some sort of confidence about the results. Now, this is very preliminary. Don't take this as face value. I don't actually even condone comparing one test to another. It was just an interesting thing, an interesting thing that we just kind of looked at and was like, all right, it's ranking them the same. So maybe there's some validity to be able to use the ideal RT as a surrogate. So some takeaways. I don't know how I'm doing on time, but it's at the end now. The ideal CT and the ideal RT provide quick, reasonable results. They make sense. They fit what we see in the field. Now the ideal CT and ideal RT, they're simple, cost-effective, rapid tests, and they're performed on one machine, one relatively inexpensive machine that most contractors, most agencies already have, a load frame. The AMPT SAP value takes a lot more material, time, and effort than the ideal CT, and a lot more training. So the running resistance index, the Hamburg wheel tracker RET value, and the ideal CT RET value, the RTI, result in similar performance predictions. So there may be some validity to using it as a surrogate. We recommend testing at 3 binder contents as recommended in some of the, the method B and the PP 105, because it gives you some idea about what happens during the production variability and what do you need to do to be able to improve, what direction. When you just have one data point, does it just barely meet? Yes, there's some validity to that. It does at least help fill out that it's going to, or you hope that it's going to perform well, but is it really balanced? You can't really balance it with just a single data point. Moving forward, we're going to focus a lot of our effort on the ideal CT and the ideal RT. Some of the questions we have is, how do performance tests of the lab produced mixtures compare with the plant produced mixtures? When we do our mix design with lab produced and then we go out to the plant, how do those index values compare? We really need to have multi-phase analysis to be able to look at the lab produced, plant produced, and production, and the compaction variability. Can we develop a reliable relationship between plant produced and lab compacted specimens and cores, the field compacted specimens? Can we, with that QC/QA, can we use performance tests as a quality control tool? Can we decrease some of the volumetric assessment during production? How do mixes perform in the field when the asphalt contents result in properties outside of the volumetric design criteria, outside of our volumetric specification limits? When we need to bump that asphalt content, we're going to need to change those volumetric limits. How do those perform out in the field? We don't know. We have to talk our management to letting us try it and paying for it. And should we consider using 62 millimeter specimens for bulk? It's just something just to think about. It's like, we have to create all these 62 millimeter specimens for all these index tests now, the CT, RT, Hamburg wheel tracker. Is it feasible? Is it possible to be able to use those for bulk? So then you have several replicates for your bulk specimens. That's just wondering, because T166 suggests that 1 to 1.5 times the nominal max. So if you're using 12.5 nominal max aggregate mixture, 62 millimeter specimen, that should work. But then I've talked to some people about it. There's concerns about the gyratory angle, the fact that the implications, how that relates to the field, the traffic levels. It's just something I'd be interested in some of the doctors out there to look into if it's possible. The never-ending questions, they're going to continue, is what test is right? No one knows. The important thing is what test is right for you? What test is right for your concerns, your distresses? What temperature is right? It's always another good one. Should we be testing the ideal CT at 25 degrees Celsius in Texas and in Maine? Should we vary the temperature and then keep the same test criteria, or should we keep the same temperature and vary the test criteria? Which way is right? The different tests, different states, different agencies do it differently. Which way is better? What aging protocol is right? That's another good one. All right, should it be 95 degrees for 5 days, 135 or 2 hours, 4 hours, 8 hours? Should we be aging the mix? Should we be aging the binder? Can we create a relationship between the aged binder and the mix and not have to age the binders? There's the aging debate's going to go on forever. The important thing is if you pick something up front that works for you. In our case right now, we're looking at what relates to field. We want to be able to do a lab, a production, a design based on lab production, lab samples, and have it relate to field. The cracking tests, yes, you need to have increased aging to be able to truly understand how it's going to age, how it's going to act out in the field. We don't have a lot of different binder sources to work with here. And after you do all that aging up front with your design, the contractor switches the binder source on you. How valid is all that aging work you did with that design? All that long-term aging? It's in my mind, it's not that valid. I think we have a little more focus on the binder aging and trying to create some relationship to the mix design, the mix aging. So you can do a short-term aging of the mix and have some confidence, some idea of the cracking susceptibility long-term. And what criteria is right? Benchmarking is all about trying to have some idea of how many of our mixes are going to go bad? How many designs are no longer going to meet our specifications if we apply this certain criteria? So what criteria is right? the association, how that associates and relates to field performance is the only true way to be able to choose your criteria. And every state, every agency is going to be different. Thank you for your time. Thank you for your opportunity. I know it took much longer than I needed to, but I took advantage of the extra time. So I don't know if you want to do questions now or, okay. Thank you, guys.
If people have questions online, Van's going to get up in a minute and ask those. So John, go ahead.
Anybody? Anybody?
No, I mean, did a great job, Casey. Great. John D'Angelo consultant. And you've done a tremendous amount of work. I do have a comment for you, though. Primarily, you were talking about a lot of these tests, that they were developed and some people just test like at 25 mostly. Well, I think you're 100% right that we can't test at one temperature because they're meant to look at a material at a certain stress level and a certain modulus. And for example, if you're using a -28 in Maine and someone's using a -16 in Texas, at those critical temperatures where things crack, if you just test one temperature, you're gonna miss those points, and you have to adjust temperature. Now, it's a little bit more complicated, a little bit more work to reestablish the testing at those different temperatures. But if you really want to look at cracking in Maine as opposed to cracking in Texas, you have to change the test temperature, not change the criteria, because the material will react differently if you just do it all at the same temperature. So it's critical to do that.
I agree.
Good morning, Casey. Thank you for the presentation. That was amazing. I thought I asked for a lot of testing, but after seeing your numbers, 3,200 tests and then so on, that's an amazing database. My question is, I assume you're talking number of tests per replicate and not mixes, if I'm not mistaken.
That's correct. Those are individual tests.
Okay. Is the number high because you're trying to achieve a certain variability or because you had a lot of mixes?
So we intentionally are, right now we're using 3 replicates for the CT, RT, and the high temperature IDT. And we just use the typical 4 specimens for the Hamburg. So the reason that we're running so many tests right now is we want to try to benchmark where our data stands. So we don't intend on keeping this up. We can't keep this up. The lab is not happy with me, and basically, so we're trying to do everything we can.
How you're defining your variability?
So right now, statistics on 3 samples, it's questionable. It gives us an assessment. Right now, it's basically, we're choosing 3 primarily because that's what the specification calls for. So we're not trying to define variability right now necessarily. But if I was to talk about the test, I would say the coefficient of variation within those replicates.
Yeah, I'm interested in seeing your database for the 76E -28. I have another question, something that caught my attention in the presentation. You mentioned retained cores for CT index testing. I assume you've done testing on the cores.
Yes, we've ran about 1,300 cores.
And how you're looking to include that into your database? Or
so right now, we haven't had any time to look at the data yet. That's the big issue with the agency. We're lucky enough to have some support. We were able to have Nico Trebouet. We hired one person that's done all of our CT, RT, and ideal CT, RT, and the high temperature IDT. He's ran majority of the AMPT. So we've been lucky to have one person that's being able to focus and work on all of this, which is huge with benchmarking, being able to do this. But
yeah, I'm very interested in seeing how you're going to include that portion into the entire work, because it's different.
Yeah, typically we just throw the cores out, just like these dispute mixes. So I just asked, can we break them first? We measure, we get 3 different measurements, so they don't necessarily meet the full specification as the parallelism of the size. But how does it need to? We're throwing them out anyway. It doesn't take very long to get them up to 25C and break them. So let's break them before we throw them out. See if the data shows anything. We like to try to make data-driven decisions instead of feelings.
I agree. Thank you.
Yep.
Hi, Casey. Thanks for the great presentation. I think you brought up a bunch of great points. Asphalt Technology with Cargill here. One thing I wanted to, maybe I have two parts to my question. First one, I'll start with a question. Are you also doing a secondary, maybe cracking test or damage test, perhaps on the side, maybe not for all 3,200, but is there another index, I think with the AMPT maybe that you're looking at as well, to kind of see what another measure of cracking performance might be giving you for the same mixes?
So yeah, that's what I was showing with. We've done work with the AMPT SAP value, that cracking indice, and the ideal CT. And there's no way I can include another test.
Well, I think that SAP will probably do. I think that, and I have not seen as much of that data as I have seen, some of the, let's say, in addition to the ideal, if I'm looking at tests with a simpler loading kind of scheme or stress strain type of setup that really stresses the binder, look at something like the overlay test or the DCT. And where I'm going with this is, something that I've been seeing, and this is, I'm going to oversimplify here, is that
I appreciate it.
If we look at these damage tests, we're looking at binder quality and binder quantity and how they're affecting our cracking performance. And it's becoming pretty clear as, I'm looking at the different tests, that some tests are going to tend towards telling you quantity is important, more important than quality, and others will go with quality. And ideal is one of those that seems to be tending towards, putting more binder is going to be a quicker way of improving your performance than putting in a better binder, perhaps. If you did the same test perhaps with an overlay tester, you would probably see that you could, improve your grade and get the same improvement by percentage, let's say, that you would instead of putting in, 0.4% binder. Which one's actually more representative of what you're going to see in the field? I think the jury's still out, and I think that's good that you're, getting all of these materials. I think all of us will use that, but I think an interesting trend we'll probably start seeing is the states that are, start adjusting designs by ideal will probably start seeing, 0.4 to 0.5% higher binder contents than states that are going with, more direct tension type tests. And we'll probably see that design starting to get approved that would have used a V grade now using an H, or E is now using a V, but used a little bit more binder. Folks that would have done a grade dump to put a higher wrap might say, hey, I don't need a grade dump, I'm putting 0.4% more binder, I'm seeing the same results. And I think we'll all wonder, did we fix the cracking problem now or not? And I think those companion tests are going to be important for us to start to understand if, make sure things don't go sideways on us.
No, yeah, I agree. But as far as an agency and many contractors in the real world, outside of the research world, we have personnel limitations, time limitations, material limitations, pay limitations. So we can't do these high level tests all the time, and especially during production. So using it for mixed design, the initial mixed design phase, there's some validity there. But we need to have something, if we're going to be able to assess the performance when we change the binder source and grade during production, we need to have an ability to quantify that performance, that change of performance. And we can't do an AMPT every 2,000 tons of mix.
Oh no, I think it's more on the data set. I meant maybe on your extremes. Maybe there's 50 points for your 3,200 points here, but just to kind of maybe have some point of correlation.
Yes. Yep. No, I fully agree.
Sorry to say some, but we're going to have to go to. We've got a few online questions we want to get to, and then we'll kind of wrap it up. Let Steve have a talk.
Okay. Yeah, we do.
Other questions from the online group.
Okay. Yeah, we do have a few questions from online attendees. I grouped them together somehow. The first set of questions was regarding the impact of specimen reheating. The question from Joe Schur asking, how do reheated specimens compare to project-made specimens? And also a similar question asked by Oak Metcalfe from Montana. He said, I have the same question as Joe. We have evidence that shows reheating Hamburg specimen never fail. while field specimen and the road course of the same mix is filled?
So I don't, if they saw that slide, that quick snapshot where I showed the Hamburg wheel tracker versus the CT index, you see that there are many mixes that fail. Those are plant produced mixes. So when you talk about project specimens, I'm assuming they mean plant produced specimens. We have failures, and that's most often addressed with the more polymer modified binder. Honestly, it works to improve the rutting resistance. But right now, I don't have a good feel as far as the relationship between the cores and the field produced mix, because we primarily do our Hamburg testing on plant produced lab compacted specimens.
Okay, fair enough. The next question is more like a comment than question from Tom Bennett with Rutgers University. He said, in a low bid system, I think it will be rare to see mix truly balanced unless there will be a pay adjustment for performance above and beyond the minimum. In most cases, you will probably see mix designed to meet the minimum cracking requirements, with this rutting simply falling in place by default, similar to what Randy had mentioned about during the introduction section. You will see mixes designed towards the balanced condition to ensure inherent variability does not result in a falling result, but a true balance may not be seen in a low bid environment. So it's a comment.
Yeah, no, and that's a valid comment. And he's obviously fully aware that we're all locked into a low bid environment. But if we want to realize the gains of these more expensive binders, we're going to need to increase the asphalt contents, and that gives some of the regressed voids options, super pave 5 ideas. Some of these other theories, and like Vermont was even saying how they, and Stacy was saying how their designs have increased asphalt contents. They found that the increase in asphalt content was part of this performance testing. And I guarantee all agencies are going to generally see the same thing, because contractors are going to want to under asphalt the mix or put as little bit as they can, because it's low bid. You can make more money.
Sounds good. Well, we do have a few more questions. Because of time, we won't be able to address them, but after the meeting, we'll get with Casey to address them. Thank you.
All right. Thank you all for your time.
All right, great job, Casey. Thank you very much. Next up, we have Steve Hafel from Wisconsin. He's a central office HMA supervisor. Steve has 36 years of experience in asphalt, 31 years with the Illinois DOT, and 5 years at Wisconsin. So Steve, come on up. Thank you very much. I'll give Steve a warm welcome.
Thanks, Randy. As he said, my name's Steve Hafel. I'm here to talk about the Wisconsin benchmarking effort. Got it. So to let you know kind of the road we traveled, back in 2014 and 15, we did some high recycle projects utilizing performance testing, kind of to see how that would help us use higher recycle. So we got onto the fact that we have to get on to doing the performance test and see how they work. Then in 2016, we actually hired an HMA specialist so we could start doing some testing. Worked great in 2017. Scott set up our testing lab. We remodeled an area, set up a testing lab, started testing, got it going. Unfortunately, he transferred. So 2018, 2019, we didn't have a specialist to do any testing. So the part about the staffing issues is real for us. 2020, we kind of reorganized some existing staff, and we were able to get our testing going again. And we continue that in 2021. Some of our research projects that we have going on, obviously, we're also with the cracking group with the NCAT and Minroad, and we're involved in NRRA with Minroad and stuff. So we've got a lot of groups that we're teaming with to learn more about the cracking and other performance tests. But we did have a project back in 2016, the end of it, Dr. Bonnequist come up with looking at our different performance characteristics of our mixes, and IFE had just come out and he used the post-peak analysis, and it really made the data work a lot better. So that was a big help. We had another project where we're looking at different performance tests. Dr. Bahia and the UW group found out that the 50 degrees for the Hamburg wheel did not work for our 58 minus 28 mixes. So that's one thing that we dropped that down to 46 degrees. And the next one NCAT did for us, the regressing air voids. And what we were at that time, Wisconsin was realizing we don't get enough asphalt in our mixes. They're too brittle. One of the regions actually said, we're going to try to fix this on our own. And they used an effective binder spec. We worked together with industry. Industry came up and said, hey, let's try regressing air voids. Other states are doing it. We actually regressed down to 3.0 voids. And that got another 3 to 4 tenths of virgin binder into our mixes. And that's all the testing that we've done has been on the regressed air voids. Another project with the UW and the team at Benke Materials and VitMix Solutions talked about the long and short-term aging. We verified we did want to do 4 hours of short-term aging to match plant mixed material. And we decided to go with 6 hours of long-term aging for our cracking test. Another NCAT project was to benchmark and develop a pilot spec for us. We gave them 18 mixes and they were able to kind of get an idea where our mixes laid and actually draft a little bit of a pilot spec for us. And this last one that we're just starting is pretty exciting for us because we are doing some of the things Randy talked about earlier. This is an NCAT project they're doing for us. And we're doing a field test section where we're going to have multiple sections where the upper layer is at different materials. It's the same mix design, but adjusted to have varying levels of cracking and rutting performance. And also we're going to do a bunch of jobs where we're going to take those 10 consecutive tests and go, how does this vary during production? If we change something during production, will it affect the results for our test? So which test? Everybody's semi-nightmare. We went with rutting test with the Hamburg wheel tracker. We're sticking with that so far. Cracking, we've been kind of through the gamut with some SCV testing and they didn't really pan out the way we wanted to when we found out the post-peak analysis was better. We did do some DCT and right now that's kind of parked. Of course, thermal cracking is important to us up in Wisconsin, but we have made some binder changes to help that. The iFit is what we started doing. And then we pushed the easy button with the ideal CT and said, it's basically a similar process. So we went and that's what we've been testing the last 2 years with is ideal CT. And we had to set up our lab. We had the Hamburg wheel tracker equipment. And then we also have an Instratech chambered so with a horizontal jig, we can run DCT and other tests temperature controlled there. And we also have the vertical jig that we can do our ideal CT, our room temperature testing at. So as we go to benchmarking, a lot of details, devil's in the details, as they say. So here we are. What mixes are we going to sample? What tests are we going to complete? What protocols are we going to use? How do you collect and store the data? We've had to go through a lot of those issues the last couple of years. So we did test in 2017 and then again last year, and we're continuing this year. This is just a breakdown based on traffic level, our low traffic, medium traffic, high traffic, and also SMA that we use on a lot of our, some of our interstates. We're trying to push that more now. And you can see MT is our workhorse. We've got most of those mixes there. And as we break down those 2020 mixes, you can see not only the traffic level, but also look at the binder modification level. It's the M332 designation, so it's standard and heavy, very heavy, extreme binder grades. And you can see we've got the S grades covered pretty well, especially the MT, but we need to make sure we fill in those other data so we can understand the performance gain we're getting with other modifications. So the mixes we benchmark were primarily from our PWL projects we had. We have PWL as our highest level quality. It actually has a test strip, so we know we get the mix lined in. We go a couple days, the mix is going good, and then we'll go out there and sample it. Our contractor partners are out there sampling a bunch of boxes for us and for them. We also locate these location of those samples. So we know by a northbound lane at these coordinates, that's where this sample test is located. So hopefully we can get that, long-term performance tied down, because we don't have really any of that now, but at least we'll have some references in the future. We also are trying to key on other select mixes, like I said, SMAs, interlayers, and try to get more mixes with polymer so we can help fill that data set up. So as far as the tests, when we get those splits from the contractor, the regions are grabbing them for us and sending them to the central office. That's the only place that the department's doing any performance testing. We have the Hamburg wheel, so we're running only plant mixed basically right now, with no additional aging for Hamburg wheel, whereas the ideal CT, we are doing additional aging to the 135C at 6 hours. That's what we're doing right now, hopefully to vet out the aging of the binder, and especially if recycling agents come to be. We've also done some without the additional 6 hours of aging. We want to get that comparison. We understand a lot of states are looking at just the plant mix or short-term age mix to try to use that easier for production testing. So we are looking at that. So keep that in mind as you look into our numbers. There's some numbers that are over 50 typically, and they might be just plant aged or short-term age materials. Ours are the minimum ones are below 50, and that's why our levels is lower, or half as much as what you saw yesterday. So the database, it's quite a thing to look at once you get all the numbers in there, and you're always wanting to add more columns, but it takes a lot to get the DOT and contractor data in there. You got to identify the test and the testing conditions. And we're also adding some automated analysis to it, so we can go and get our average and standard deviations out of it. We're plotting histograms and doing those cumulative distribution plots, S curves that we saw in the research that NCAT did for us. So they're coming in pretty handy. So the database right now has 51 columns, a lot of project info, like the county the project's in, and information of the location of the test, the mix info, the gradation and the type of binder and such, and other properties too, like the aggregate type and in the source actually also. We also have the Hamburg wheel tracking info and the results for that, the ideal CT info and results. Our old database, we actually had all those other tests we were trying. So the current one is cleaned down to just these tests. And of course, comments section in case there was, the testing was part of another NCHRP project or something we've had in the past. We are trying to make it simpler. We're going to start implementing a form for the contractors to put all their information in for their testing. They can send it to us and we can auto-populate our database with it. And then we can easily compare our test to the contractor's test. One way when we're looking at Hamburg wheels is you're always looking at the number of passes or maybe the rut depth if it exceeds the 20,000. And we've got the full gamut of the degrees of rutting. So what I asked our staff to look at is drawing out that bottom axis. So it's actually two axes in one. We've got the Hamburg wheel passes, from 0 to 20,000. And for those mixes that do make the 20,000 passes, we've added a more continuum of the scale. It's very simple. All we did is add another 1,000 passes for every millimeter rut depth to be below 12.5. So I hope that doesn't upset the scientist in you, but it actually works pretty good because now we can see the continuum of the test and the spread of rutting resistance that we really have. Initially, we were looking at like a 40 CT index. As you can see, there's a lot of mixes below that. And remember the CT index is the plant mix plus the 6 hours of 135 aging. And the Hamburg wheel is only plant mixed or short-term aged. So there is a considerable amount of concern for our cracking resistance. And there is some concern. We had one HT binder that we would have liked to see make 15,000 passes. It didn't, and several the low traffic mixes or the S binder mixes that did not meet that line. So that's the ones we looked at, but you can see we kind of got that continuum from the upper left to the lower right. And the sweet spot is upper right is where we want all of our mixes if possible. This is the same thing, only instead of using binder grade to get the different thresholds for Hamburg wheel, we're actually using our traffic levels. And it doesn't, Hamburg wheel trends much better with binder than it does with, the traffic level, especially in our case where we have areas in the state where we have outstanding aggregate structure. And so those LTs and MTs, the same aggregate is used as HT, so they can perform very well all the way along the continuum. So that's why they're spread out. Our HTs are up there where they belong though. So we did set up a pilot special provision that we hope to have. We're going to try to get it on all 5 of our regions completed by next year. So we're only going to do 5, kind of just sticking our toe in the water. We are definitely taking baby steps. When you're in DOT for 36 years, you tend to be pretty conservative. And so we're taking steps to move toward it. We have Hamburg wheel and the ideal CT and the pilot spec. And the criteria we used was similar to what you saw there, the 10, the 15, and the 20,000 for the S, H, and V binders, and the E also. And we have the ideal CT. We're looking at using 30 at first to try to get capture our worst cracking susceptible mixes. And we also added in the stripping inflection point of 8,000. If you look at that plot, it kind of gives you a better idea for the 30 for the ideal CT, those mixes that are below it, we end up failing about 15% of them right now. The 40 was higher. We could have went with that. We're trying to get a balance to work on our worst mixes. Industry understands that we're going to have some mixes that we have to fail, otherwise this process isn't worth it. But again, we don't want to fail all of our mixes and impact a lot of designs at a time. Then as we look at the Hamburg wheel, you can see that the H binder mix, along with several of those LT or S binder mixes, did not meet the design criteria or the criteria for the Hamburg wheel passes. I wanted to take note of that circled one, because if you really look at the Hamburg wheel and the SIP, that circled one is the only one that failed SIP also over the Hamburg wheel ones. So all the Hamburg wheel that is less than 10,000 failed on the number of passes and the SIP. And then there's another additional point on the SIP that failed. And if you can see that point, the mixed design F there, that one actually slid in there in the number 6 spot for the SIP. Otherwise, since this analysis is basically similar, you're looking at they're showing us probably that we have a rutting or a stripping problem, maybe more than a rutting problem. We're going to look at this also. We're working with FAN now to try to use that analysis for the stripping number and the rut depth. So we're going to see if that tells us anything more and try to understand is our rutting problem, our concern, really a stripping problem? And it very well might be, because several of these mixes are in an area that we know we have stripping aggregates in that part of the state. So we might have more of a stripping problem, and we definitely have a cracking problem. It was good to have all these points and to get a good big picture view of them. And remember, this is all data that after we regressed our air voids at 3%. So if we would have done our 4% mixes, I'm sure we would have had more of them that would have been down and to the right and more cracking susceptible. So those are the results of our starting our benchmarking efforts. We're trying to keep things going. We realize, with Randy's list that they've been working on with the FHWA, we're going to look at that closer, this coming fall and winter to see what steps do we need to take. But we need to do a lot more analysis on this data to try to get where we're at, and a lot more data points too, and especially in those modified areas. That's all I have on my presentation. If we have any questions.
I need a consultant. That was some great stuff you had there. And I think one of the things that I think is really key, and it was in the data, is that you regressed your air voids. So now you have that little bit higher binder content than you normally would have in the past. There's been a lot of discussion about, we put polymers in some of these tests on identifying the improvement with polymers. But there's a catch to that. You have to have enough binder in the first place. So if I don't have enough binder, I can put the best binder in the world, it's still going to crack. So I think, some of your data clearly shows that it's a combination of both. I got to have a good binder and enough of it. And, and it's you're always balancing. I can take a crappy binder and put more of it in. I'm going to get better cracking. But maybe if I had a really high quality polymer modified binder, I'd even get superior, but I can get both. And I think your data goes a good first step to show really that key thing there.
Thanks. Yeah, clearly that, we've had some data to the right that was very rut resistance, but some was very elevated. So we know that we're getting good crack resistance to it. So we've really got to identify what's going on with that material that it was so elevated in cracking resistance.
I see if I had to promise Randy that I would be short so I could approach the microphone again. Thanks for the great presentation. I think, in agreement with what John said, and I think, the data showed some very interesting trends. So thanks for that. I'll just maybe keep a short statement on this. Do you think it would be a good idea for maybe folks that are putting together databases of ideal data, yourself or others, that we, just start putting maybe a small piece of data entry in our report page that says, did the sample, crack in 2 pieces in tension, or did it, have, three-piece failure, with a shear failure, essentially, planes on it. Was there bulging under the loading heads, or was there not? Was there compression damage? I think at some point we're going to come back and want to look at, whether we need to do other temperatures, whether we need to maybe separate the criteria for samples that fail in, in pure tension and those that don't. And I think that will save us a lot of retesting if we just capture that, maybe in a numeric 0, 1 or a scale or something right now. And later on, we'll just have it, or we won't use it, but I don't think it adds a lot of extra work.
Yeah, that's a good point. Is we always look at the number and get the quantity, but we don't have like the characteristic or quality of the result. And we don't track that. We are, we're grabbing something and trying to, get the testing done and kind of the dust settles. And then you go back and look at the data and you realize, oh, I wish we would have done this and wish we would have done that. And every state, I'm sure, is going to go through that as they go through this process. And that might be something that we wish we had. I don't know.
Yeah, it would just add, 10 seconds to the data entry today, and maybe we'll need it later. Thank you.
Yep.
Hey, Steve, thanks very much for the great presentation. A few questions and comments coming from online attendees. A question from Chris Wong asking, have you considered differences in plant aging for mixes with warm mix asphalt?
No, we haven't. And it does present a concern, is the warm mix and what type of warm mix it is. And I think we do have to look at that. A couple of the mixes that were on the less passes, they are warm mix and stuff, and we don't know if the warm mix chemical still was activating there and making that mix softer or not.
Next question from Oak with Montana DOT, asking specifically about the Humber wheel tracking test. How are you calculating stripping inflection point? Are you using whatever equation the equipment is using, or are you evaluating it externally with some other polynomial function, for example, using our DOT equation? I think that's something we discussed briefly yesterday. So.
Yes, we are using the Instratech results and stuff, but we are comparing that to the Iowa one in some instances, and we haven't seen much difference. So we haven't done all of it through the Iowa analysis.
The next question from Haida. Now asking specifically about the long-term aging, so you mentioned like the 6-hour 135C. So have you considered the mixture thickness during aging? And also what is the reason behind selecting this specific aging protocol for long-term aging?
Well, we did want to get something so we could affect the binder aging and stuff like that. And there is a protocol spelled out to put it in a pan 1 inch thick and everything. So that is somewhat set on that aging protocol that we have. And it was just through the research project. We did a couple different times and said that that was an important factor to get us a reasonable cracking test result. And it definitely was much different than the non-aged material or the non-long-term aged material.
The next one is more about the comments. Great to see so much data has been collected. A big takeaway seemed to be that there will be a large difference in what the minimum ideal CT specification should be. For example, man was saying like 140, Wisconsin was talking about 30. It really illustrates the need for each agency to do the benchmarking piece to better understand what is appropriate for their own mixes, binders, and climate, not just take a number from someone else and implement in your own states.
Exactly. That's when you hear from different people and we have numbers all over the board, you do need to take into account, what their aging is protocols are, and then, what are their normal materials. And we are seeing cracking. So we still believe we probably will have a cracking problem, considering we had a bad cracking problem before we went through our void regression. But, we're going to have to try to improve the cracking resistance, and you don't want to throw out every mix design the first time through.
Yeah, I agree. And also, I guess just for clarification, like Wisconsin, when Steve was saying like a 30, that's after long-term aging. So that's a little bit different from what other state has been talking, which is based on short-term aging. And also, I fully agree with what Steve said. It's, when we talk about the ideal CT testing and criteria, we need to also specify the aging condition. Even the short-term aging can be different. Since some states do 4 hours at 135C, some states do 2 hours at compaction temperature. And that can be a huge difference in terms of CT index results. So we're not, trying to compare apple to apple if, all these agents are different. All right, I'll give the spot to you.
All right. Yeah, just kind of on that topic, I was curious, you mentioned that you were looking, I think, at that offset from the long-term aging with the 6 hours versus plant aged. I was curious if you could maybe provide a little more detail of what you're seeing because of that significant difference in criteria. And then also you mentioned the possibility of being able to use an offset like in acceptance, possibly in the future, if maybe you're monitoring if that offset's staying pretty similar across like a production run. Just wanted to see if you could share any more on that. Brett Williams, sorry, Napa.
Thanks, Brett. It was very confusing when looking at it because a lot of the data is half as much as the plant mix material, and a lot of data is fairly close. So it doesn't appear that you can just say, take your plant age material and multiply it by 0.6 and that's your answer. It probably is going to vary from 0.5 to 0.8. And so we've got to identify why those materials that had 0.8 and why some other materials had 0.5. And, we were talking about plant aging yesterday in the silo, and maybe those mixes that didn't change a lot were aged in the silo already and had some of that earlier aging done. I don't know, but there is not an easy answer from the data we have just looking at it. We haven't really analyzed it and what's the difference between some that don't drop very much to those that drop in half, consistently. So that's not going to be an easy one as far as I can see on the surface.
All right, thanks very much, Steve. All right, there may be a few other questions in the chat that I'll ask Fan and Steve to kind of get together and see if we can respond to those on the Zoom. So we're going to take a break in just a second, but I wanted to, this next part of the program, the last part of the program is where we're going to do breakout sessions. And from planning the program, this is the most challenging thing to do. So I've asked several people to be facilitators in here. Van will give out some instructions a little bit later, but also we've got facilitators online. And we had originally 20 facilitators online. We're going to drop that down a bit. I'm going to call out the names of the people that we still want to be facilitators in the breakout groups online. And that's Tim Aschenbrenner, Tom Kane, and Tom, if you're on, we need your name on the Zoom call to show up as your name below your picture. Fuji Joe, Nam Tran, Alan Carter. Alan, I know I emailed with you this morning. I hope you're able to connect. Edith Arambula, Jason Blomberg, Jim Musselman, Travis Walbeck, Nathan Moore, Marty McNamara, Casey Nash. Casey's doing double duty today, and Vince Allison. So again, let's take our break. We'll get started back at 9:50, so it's a little less than a 20-minute break, but be back in here promptly so we can get started. Thank you.
All right, good morning, everyone. Let's go ahead and get started with the breakout section. My name is Fan Ning. I'm with NCAT. Up next, I will just give a quick introduction about how we're going to handle the breakout section. Basically, what we want to do is to have discussions. As we discussed over the last few days as part of AAPT and yesterday, this morning about the balanced mix design. There's lots of questions that we have not reached agreement. This is where we want to have discussions to get opinion from the contractor side, from the DOT side, from the academia side. So basically, we want to make it interactive. So feel free to speak out and be engaged. Okay, let me see if I can get this working. Okay. So this is how we're going to handle the breakout groups. I think we have roughly 50, 60 people here in person. We're going to divide you guys into 6 breakout groups. Basically, the way we're going to assign the group is by your birthday. So if you ask me my birthday last night, 9 o'clock, I probably don't remember that, but this morning I feel pretty good about that. So I'll provide more information a little bit later. And for the folks online with us, we're going to do a 13, okay. All right, we're going to do 13 breakout sections. You don't have to do anything if you're on Zoom. Zoom going to handle automatically assign you to one of the discussion groups. So there are 4 topics that we think are very important regarding the implementation of balanced mix design. Those are the ones that has been a lot of discussion, and this is where we want to get opinions spoke out. We're going to talk a little bit about the balanced mix design approaches. As we all know, there are 4 approaches. Each have its own advantage versus disadvantage. And then moving next, we're going to talk about the performance testing criteria. It's very important to select the robust performance test, but where do we set the limits, for mix design approval versus production acceptance? I mean, there are different approaches, and that's what we're going to focus on in the second section. Moving next, this is where we're going to talk about the quality assurance. Balanced mix, excuse me. Balanced mix design is not only about the mix design phase. This is where we also see the importance of incorporating performance testing in quality during production to make sure the mixes that come out through the plant and placing in the field still have balanced performance in terms of rutting resistant and cracking resistant. How do we handle the performance testing in quality assurance program? It's still a big question that needs to be discussed. Finally, we're going to talk about aging. I think there's lots of discussion about how we handle aging, short-term aging, especially long-term aging. We know mix design, when we have a little bit more flexibility and time, we can handle aging. But how do we handle aging in production, where we need quick turnaround on the results so that the producers can make a decision whether or not they need to make adjustment or so that's something we're going to discuss in the last session. The way we're going to handle the section, the breakout section is we have pre-selected facilitators to help introduce each topic. We have six facilitators here and 13 online. Thank you very much for those who volunteer to help. We appreciate your assistance on that. And after the facilitators introducing the topic, each person in your group will be given, 1 minute of time to share your opinion and thoughts. I mean, there's no right or wrong. We all have different opinions. This is where we like to have open discussion. And after that, we have prepared a short survey questionnaire. So basically, we prepare some, questions based on what we discussed, and so that everyone can, put your, opinion there in the chat box, or you're just using like a pre-selected multiple choice, so that we can collect all the information from the groups, not only people here, but also folks online. And at the end of the breakout section, Randy going to come back here to share a quick summary of all the responses that we have collected at that point. And then after that, we're going to move on to the next topic. So basically 4 topics this morning. So I mentioned earlier about the survey questionnaire. If you have your smartphone with you, what you need to do is to open your camera and just point your camera to the QR code. And then that should take you to a web browser where like the pre-selected question is going to pop out at that time. And then you just need to, select the choice that you feel most reasonable based on your understanding of balanced mix design. If the QR code does not work, there is a URL provided at the bottom of the QR code, and also it's shown on the handout that we passed out earlier this morning. It's aub.ie/BMD breakouts. So basically, after you scan the code or put the URL, you're gonna see a screen look like that on your smartphone. Fairly easy and straightforward to use. So for the breakout groups here, what we're gonna do, as I mentioned, we're gonna divide the group by your birthday. So if your birthday is on the 1st to the 5th of the month, you're gonna be group number 1. 6 to 10, that's gonna be group number 2, and then so for the rest of the groups. So one thing I would like to ask is for the facilitators here, if you have your handout with you, and if you turn to the very back, if you have a number, that's you are the one that we need your help to guide the discussion. If you don't mind, if you can, read your book out so that for people to see like where you are located. All right, we got David there, we got Chris, Todd, and Scott, Johnny, and Derek. So maybe what we'll do, we'll ask you guys to move a little bit so that we can spread out the group. So maybe what we will do is let's do like group number 1 over here, group number 2 here up front, and group number 3 there. And then we do 4 on the right back corner, and the 5, that's where Chris is, and then 6 over there. Okay, all right, David already got his spot. So that's how we're going to handle the breakout sections for in-person participants. So look at your, the guidance we provided here based on your birthday, find your group mate, and get ready for discussion. One quick note I will make while you guys are moving around, it's especially for the online participants, it's when you scan the QR code, you got to the questionnaire. If you're already pre-logged in with your Google account, I mean your personal Google email account going to be shown on there. But we're not collecting that information. It's just because like we are using Google form to do the questionnaire. So that's the only reason why your email account is showing. We're not collecting that information. What we ask you to provide is your professional email account that you want to be included. So. Yeah, I think the birthday thing works really well. Okay. Look like we got a little bit bigger group on number 4. But I say overall, it's pretty fairly well distributed. Okay. All right, let's get started with ready to go. Design resource guide. This is available on NAPA website. I think we briefly talked about that yesterday. Okay, thank you guys. So as we mentioned before, this is like live kind of like information, since we know like a balanced mix design is such a hot topic, and at the same time it's a moving target, right? There's lots of new informations about like different performance tests, different criteria, how we deal with aging. Those information are coming out as we, as time goes. So that's why like, we over the last a year or two, we have been working with NAPA to put together this, resource guide website so that we try our best to keep, information up to date. So basically what we have on this, on this website, include some basic information, as you can see there, talk a little bit about the definition of balanced mix design, why we need balanced mix design. I think we all recognize there's, lots of, opportunities and benefits associated with implementing balanced mix design. So this kind of like provide a quick summary of, what we think is the benefits of implementing balanced mix design. More importantly, which personally I like this website a lot, is it does have a good amount of information. So working with NAPA, and we decided to group them into like 4 blocks. As you can see at the bottom of that web page, the one on the left is balanced mix design approaches. The second one is the performance test resources, and then implementation efforts, and then finally on the right side is training and a resource. I will kind of like do a quick walkthrough so that to guide you through the website, so that it will be easier for you to find the information that you are interested in whenever you get back to your office, home. So if you click on balanced mix design approaches, okay. So this is a page where we talk about the 4, approaches that we all discussed, approach A, B, C, D, with different degrees of flexibility on how we control volumetrics, in addition to implementing the performance test. And then if you click on like approach A, this is basically the same flow chart that we have been using. So hopefully that will give you a good idea of what we mean by each of those approach. And we have the same thing for approach B, C, and D. So, so I think we already got a good discussion, so I'm not going to spend too much time talking about that. And then the second block of information we have on the website is called the performance test resources. So if you click on that, so this is kind of like a summary of all the performance tests that has been used in previous asphalt research. Up front, we provide some guidance on how we should select the performance test. As we talk about, some of the factors are important. For example, we need to make sure there's a good correlation between the lab result to field performance. Also, we want to make sure it's sensitive to mix design variables, among other factors that we think are important. But the centerpiece of this block information is the test itself. So we group them into 3 groups, like a cracking test, rutting test, and a moisture damage test. For each of the performance tests included on website, we prepared a 1-page summary on that specific test. For example, like if you are, agency or contractor, you want to learn more about, the APA test, you go to that picture, you click on the picture, and then that's going to take you to a 1-page summary. Some of the performance tests, there have, for example, there we go, thank you. So this is kind of like some quick, sweet summary of that test. For some of the performance tests, we also provide videos attached to the test, so that it provides a little bit more information about how you run the test, how you analyze the data, how to use the test. Most of the videos were made from previous efforts led by FHWA or NCHRP. For example, like TTI did a study for NCHRP. They put together really nice videos for the cracking test. All right, look like we got some website issue, but once you get back home, you should be able to watch those videos. And we have been discussing with NAPA, I think hopefully over the next few months or a year or so, we're going to work on some other videos for the performance tests that do not currently have a video available. So hopefully, that'll provide additional information to our industry. And then moving to the third block of information, which is implementation efforts. So this is the area where we want to provide some most up-to-date information about what each state has been doing. And so this is a part that I like, the most personally. This is a very interesting, interactive map. So it's color-coded, as you can all see here. Basically, we identified 13 states using different BMD approaches. Approach A, approach B, approach C, and D. And they are highlighted using different colors. In addition to those BMD approach states, we also identify a few more states, which we call them pre-implementation. What we mean by saying pre-implementation is that the states, they may have either a routing test or a cracking test in their current specification, but they don't have both. So in that case, they are not really a true balance mix design states because, by doing balance mix design, we want to find a balance between those two, cracking evaluation and the routing evaluation. So, and also if you click on one of those states, if you I want to look at Tennessee, there we go. So this give you a little bit more information about, what Tennessee is doing about balance mix design. It talk a little bit about their volumetric requirements, followed by the discussion on the performance testing in terms of whether or not they use a test for mix design only, production, or both, and also some information about the criteria. So every color-coded state on that map has a one-page summary attached. So whatever states you are most interested in, click on the map, and then you should be able to find more information. One thing I want to highlight here, this is kind of like still in progress. As more information become available, NCAT and we have been working with NAPA to update the information. So at least there are two or three more states. We already prepared the write-up. Right now, they are under state review. Whenever that got completed, I will send to NAPA for Brett to work with his team to upload those information to the website. So basically, it is a kind of like a live website. So the whole idea is to keep all the information up to speed, so that we don't look at the information that was 2 years old. It's the most current information. And finally, on the very right side is the training and the resources. We have been talking, this balance mix design is such a hot topic in our industry right now, in our community. So there's lots of good information out there from from the research perspective, from the training perspective, or from the implementation perspective. So this block of information on the website to provide lots of good information that you can go to find more information. So basically, the NAPA put this website together to make sure all this great information is available to each of us, so that hopefully this can serve as a one-stop, for information search. So hopefully you will find this website useful. The last thing I will make about this website is at the very end. If you go to the very bottom of the page, there should be a places where we ask you to provide the feedback. Okay. Okay, if you go to implementation efforts, and there we go. All right, thanks. So this is where if you look at the website, you look at the map, you feel like, oh, some of the information that we provided there need to be updated, or with new information that come out from a specific state. Send us an email or provide your response here. And someone from NAPA will reach out to you, or we will work with NAPA together to make sure those questions or comments are addressed. Basically, this is a resource to everyone, and we want to take advantage of this great resource for our industry, and to provide the most accurate and up-to-date information. So All right, I think Randy is ready to go. So with that, thanks again for the great discussion on the breakout sections, and I'll turn it over to Randy so that he can give a quick summary of all the responses that we have collected so far.
All right, well, thank you all for participating in the breakout sessions. It probably went a little smoother in this room than it went with the virtual breakout session. So for those that are still connected virtually, hopefully that was worthwhile for you. I'm not sure if Fan asked you when he got up here, but I'm going to ask now. During the discussion with your breakout group, did your opinion change of any of those topics? Raise your hand if your opinion changed by hearing some of the feedback from others. Okay, a few hands are raised. Good. Again, these topics are all things that I think are yet to be settled, and there may be different decisions by different organizations going forward. All right, so I'll kind of get to this. One of the first things was just kind of get a feel for the cross-section, the demographics of what we've got. So we got more input from agencies. The second most group was the producers and contractors or associations. And then the third largest group was researchers, academic institutions. So we had 100 and really, I think it's 105 or 106 responses. As I was copying and pasting, the numbers kept going up. But so the first question was about the BMD approaches. Which of the BMD approaches do you prefer for mixed design approval? And here's the results of your choices. Okay, so it's like 32% like method A or approach A. 27% volumetric design with performance optimization, that's approach B. So it's pretty evenly distributed there. You know, there's the group that like to go to performance design right off the bat. At some point, hopefully we'll be able to kind of sort through more of the details of if there's a preference that's different for contractors and associations and agencies. So that'll come later as we have time to sort through the information a little better. The second topic that you talked about was setting criteria. And we ask you to agree or disagree on a scale of 1 to 5 about these sources of information. Okay, so for benchmarking data, most of you agree or strongly agree. So 31% and 52%, 53% either agree or strongly agree that benchmarking data is important. Using PMS data linked with BMD test results. This is more evenly distributed, looks like a normal distribution, maybe skewed a little bit to the agree side. Criteria from other states, more on the disagree side, either strongly disagree or disagree. That's about more than half. More than half were kind of in those two categories. And the last source of information would be lab to field correlations from experimental test sections. And looks like, again, most people either strongly agree or agree that that's a really good source of information. Topic 3 was about using performance test and quality assurance. Okay, and we asked the same question kind of at the initial stages or beginning of implementation, and ultimately what you would prefer for, and we only gave you 3 choices here. There are lots more choices than 3, but just to kind of make the discussion kind of go along and then summary kind of go along. So which approach would you prefer for QA at the beginning of implementation? Looks like the vast majority said option 2, which is verify BMD properties at startup as initial verification lot, then proceed with traditional acceptance quality characteristics. And then the other third roughly said not to use BMD tests for quality assurance. That's the initial response at the beginning of implementation. But ultimately, it looks like the choices flip. Okay, so more people prefer to go to the third approach, which is basically replacing volumetrics used as acceptance quality characteristics with BMD test results. With a little more than a third still want to use option 2. That's sort of what we expected. It would kind of flip from initial to ultimate goals. Dealing with aging. Okay, again, we asked you to agree or disagree on a scale of 1 to 5 about these 3 things. They were worded a little different than I think the discussion topic, so hopefully that didn't confuse you. But the first one is dealing with aging. Mixed aging is not a critical issue at this time, and most people strongly disagree with that. The second one is mixed aging must be included with mix design cracking test for surface mixes, and we got specific there. Surface mixes. And looks like either most people either agree or strongly agree with that. And then dealing with aging will somehow be assessed with quality assurance cracking test. And again, looks like most people either strongly agree or agree with that approach as well. So that's a quick summary. It's not real in depth, but I think it provides a good picture of kind of where people are thinking. So again, thank you all for participating in that. I wished I had been able to sit and listen in on the discussions. I was trying to get those responses to load live, but basically had to wait until everybody finished all the discussion for it would populate into the Google Forms. So this was a learning exercise for us. Hopefully it was something worthwhile for you guys. So look forward to working with you all again as we kind of move toward implementation of BMD. Hope you all have a very safe and happy Labor Day weekend. Get home and enjoy time with your family. And so Godspeed.